Have you ever wondered why the sky growls after lightning strikes? That deep, rolling sound, thunder, has echoed across Earth since long before we had words to describe it. There's a sound that shakes the sky, a sound so ancient our ancestors believed it was the voice of the gods. But thunder isn't just noise, it's information. A sudden, violent message from the atmosphere, revealing secrets about the power surging above our heads. Tonight, we're not just asking what causes thunder, we're asking, what does thunder reveal about the hidden forces shaping our planet, our weather, and even life itself? Before we begin, take a second to subscribe, and let us know in the comments where you're watching from and what the weather is like tonight. Because if you've ever been kept awake by a storm, you already know. The sky has something to say. Chapter 1, Thunder. The sky's sudden roar. There is a moment just after the flash, when the world holds its breath. You see it before you feel it. A white-hot crack of lightning rips the sky apart, searing itself into your retinas like a ghost. And then, silence. Just for a beat, long enough for your brain to wonder if it imagined it. And then, from somewhere in the distance, a low growl begins. It rolls forward like a wave of ancient fury, building, rumbling, vibrating everything around you, until it crashes into your chest like a forgotten heartbeat. That is thunder, but what exactly are we hearing when the sky growls? To understand thunder, we have to start with the bolt that always comes first, lightning. You can't have one without the other. Lightning is a sudden electrostatic discharge, billions of volts surging through the sky in an instant. It heats the surrounding air to temperatures hotter than the surface of the sun, up to 30,000 degrees or more, in less than a millisecond. Now imagine air, something invisible, something we usually don't even think about, being forced to expand at that kind of speed. The result is explosive. The air doesn't just move aside, it tears violently. The molecules are shoved outward faster than the speed of sound, creating a shock wave that radiates outward in all directions from the lightning bolt. That's the sound we call thunder. It's not the lightning itself making the sound, it's the air reacting to the lightning's sudden presence. It's pressure, trauma, movement, energy. And in that moment, the sky screams. What makes thunder so strange and beautiful is that it almost never sounds the same twice. Sometimes it's a sudden sharp crack, like a whip. Other times it's a rolling, guttural boom that rumbles for seconds, echoing through valleys or bouncing off buildings like a ghost trying to find the door. Thunder isn't a single sound. It's a collection of sounds, all arriving at your ears at slightly different times, traveling through layers of the atmosphere, bouncing off hills, trees, clouds, and terrain. You're not hearing the lightning bolt from one fixed point. You're hearing the entire length of the bolt, sometimes stretching several kilometers across the sky. Each section produces its own burst of sound. Some parts of that sound reach you quickly. Others echo and scatter, reaching you seconds later, distorted, layered, fragmented. This is why thunder can roll for so long. It's not an echo in the traditional sense. It's the tail end of a sky-wide explosion still arriving, and that's why thunder is so haunting. It's not clean, it's messy like nature itself, untamed, unpredictable, raw. One of the most fascinating aspects of thunder is the delay, that gap between the flash and the rumble. It's more than dramatic effect, it's a measurement, a reveal. Light travels at nearly 300,000 kilometers per second. Sound, on the other hand, only travels about 343 meters per second through air at sea level. That's a huge difference. So when you see lightning, you see it almost instantly. But the thunder, that takes time to reach. This is where the old counting trick comes in. You count the seconds between the lightning flash and the thunderclap, then divide by 3 to get the approximate distance in kilometers. 5 seconds means the lightning struck about a mile away. 10 seconds, it was 2 miles. And if you ever see a flash and hear the boom at the same moment, you don't need math to tell you that lightning was right on top of you. But here's what most people don't realize. The way thunder travels can tell us more than just distance. It reveals temperature gradients, wind layers, pressure zones, and the makeup of the atmosphere itself. Scientists can use thunder, its shape, its delay, even its pitch, to learn about what's happening in the sky above. Because thunder in many ways is a diagnostic tool. The sky isn't just roaring, it's speaking. If you could freeze time and examine a lightning bolt mid-flash, you'd see it's not a straight line. Lightning twists and forks. It splinters and branches out in jagged, unpredictable paths. Each of those branches sends out sound, which means thunder is shaped by the geometry of the bolt itself. When you hear a crisp, clean crack, you're probably close to a single, strong discharge. When the thunder rolls and rolls like a freight train across the heavens, it likely came from a long, complex, forked bolt that covered a wide area of sky. Even the angle of the bolt matters. A bolt that streaks directly overhead produces different acoustics than one that zigzags away toward the horizon. Sound behaves differently over flat plains than it does over forests, mountains, or oceans. In urban areas, thunder can bounce between buildings, creating strange, overlapping echoes. In the desert, it might carry for miles with eerie clarity. In a dense jungle, it becomes muffled, swallowed by foliage and moisture. So when you listen to thunder, you're not hearing just a sound. You're hearing a map of the lightning's journey, a kind of sonic fingerprint. Ancient cultures didn't have weather satellites, Doppler radar, or thermodynamic models. They had experience, and that experience told them one thing clearly: when the sky roared, something powerful was happening, something to be feared or worshipped. In Norse mythology, thunder was the hammer of Thor, striking down giants in the heavens. To the ancient Greeks, it was Zeus, hurling lightning bolts from Mount Olympus. In many Native American traditions, thunder was caused by great birds, the thunderbirds, flapping their wings high above the clouds. And while we now understand the physics of thunder, those myths weren't foolish. They were a kind of truth. Because thunder is powerful, it is something beyond our control. And for most of human history, it truly was the voice of something higher. Even today, thunder has an emotional pull. It wakes us from sleep. It stops conversations. It makes children, and sometimes adults, run for cover. It's not just sound, it's presence. It's the sky showing up. Most people think of thunder as harmless. After all, it's just sound. Right? Not quite. Thunder can produce shockwaves powerful enough to shake buildings. If you're close enough to a lightning strike, the thunder can be deafening. There are recorded cases of thunder causing structural vibrations strong enough to break windows. Some survivors of near lightning strikes report temporary hearing loss, disorientation, or the sensation of pressure deep in the chest. That low-frequency rumble we feel, it's not just heard, it's felt. Sound, after all, is vibration, and thunder carries some of the most intense natural sound pressure levels on Earth. But beyond the physical, thunder plays a role in human psychology. It can trigger startle reflexes, increase heart rate, and activate the brain's fight-or-flight system. Our ancestors were wired to respond to loud, sudden sounds, and that instinct remains. That's why thunder is used in films, video games, and haunted houses. It activates something primal, something old. There's something poetic, even musical, about thunder. The way it swells and falls, the way it echoes. No two thunderclaps are identical. Some are short and percussive, others roll like a timpani across the sky. Sound engineers and scientists have studied thunder not just as noise, but as waveform. By analyzing the frequency spectrum of thunder, researchers can determine the altitude of the lightning, the density of the surrounding air,
and even the temperature gradient between layers of the atmosphere. Some scientists are even experimenting with using acoustic thunder data to improve weather models. Imagine a future where we could predict the strength or path of a storm based not just on radar, but on how the sky sounds. In this sense, thunder becomes more than a byproduct of lightning. It becomes a language, a signal, a code we're only beginning to translate.
Chapter 2. When air becomes fire, the birth of lightning. High above your head, in a cloud that seems silent from below, something violent is stirring. It's not loud, not yet, but it's tense, charged, restless. A storm cloud, a thunderhead, is more than just water vapor floating in the sky. It's a living system, a churning, climbing tower of heat and energy, reaching upward, sometimes tens of kilometers tall. Inside it, warm air surges toward the top, while cooler air sinks. Water droplets freeze, melt, and refreeze again in an endless cycle of collisions. Ice crystals brush against hailstones. Droplets rub against particles of dust, and in that relentless dance, friction builds. Separation begins. Positive and negative charges start pulling apart. The lighter, positively charged particles rise toward the cloud's top. The heavier, negatively charged particles sink toward the bottom. This invisible tension, this growing imbalance, becomes the heart of every lightning bolt. Like a balloon rubbed on your sweater, the cloud becomes a massive, unstable generator of static electricity. But this isn't child's play. The voltage inside a storm cloud can climb past 1 billion volts. The air between the cloud and the ground can no longer hold itself together. Air is supposed to be an insulator, a buffer. But under enough pressure, even the air gives way. And then it breaks. Before the lightning flashes, there's a preparation, a silent read. Scientists call it a stepped leader. A branching, invisible thread of negative charge that begins to creep downward from the cloud, feeling its way toward the ground in jagged, trembling steps. It moves fast, over 300,000 kilometers per hour, but to the eye, it's still invisible. It's looking for a connection, and the ground, sensing this approaching force, sends out its own invisible tendrils of positive charge, rising from trees, rooftops, even your body if you're out in the open. Then comes the instant of contact. One tendril from the ground meets the descending leader. The circuit is complete, and in less than a microsecond, the full current of lightning surges upward, not downward as many believe. What we see as the lightning bolt is actually the return stroke, a brilliant, blinding river of electricity racing upward along the path the leader carved. It's not just one flash, often it's many, flickering back and forth up to 30 times in under a second, giving lightning its trembling, strobe-like appearance. Each stroke heats the surrounding air to over 30,000 degrees Celsius. That's 5 times hotter than the surface of the sun, and in that moment, the surrounding air doesn't just move, it detonates. This is when thunder is born. The air, unable to expand fast enough, sends out a shockwave. That shockwave, carried through the atmosphere, sculpted by terrain, twisted by wind, becomes the rolling roar we hear moments later. But the bolt itself, the path of fire through the sky, is far from simple. Most lightning strikes are cloud to cloud or intra-cloud, meaning they flash inside the cloud itself, never touching the ground. These light up the sky in wide, flickering bursts, illuminating the entire storm like a paper lantern. Only a fraction of lightning ever reaches the earth, but when it does, it reminds us how thin the veil between sky and soil really is. Lightning is not just a force of destruction, it's also a force of creation. Each bolt rearranges the chemistry of the air. It breaks apart nitrogen and oxygen molecules, recombining them into nitrates that fall with the rain, nourishing soil and feeding plants. The same strike that can kill can also fertilize, and sometimes it does both in the same field.
There's something sacred about lightning, not because it obeys us, but because it doesn't. It speaks in the language of power, of imbalance and sudden correction. In physics, lightning is a solution, an abrupt answer to an unresolvable tension, a massive discharge that restores balance in a way only nature understands. The size of the bolt doesn't always match the strength of the sound. A short, nearby strike may shatter your ears, while a long, wide-reaching fork far above the clouds may sound like a gentle sigh. But both are signals, both are sudden balances reached through violence. Inside the cloud, before the flash, the world is chaotic. Collisions occur at a molecular scale, millions of times per second. Ice pellets slam into rising droplets. The storm builds its pressure quietly. No warning, just the slow climb toward inevitability. Then, suddenly, resolution. That's what lightning really is. The moment a storm finds its voice, the earth is no passive observer. It plays a role in every strike. Mountains, trees, skyscrapers, even our own bodies. All conductors, all potential partners in this cosmic handshake. Ever wonder why lightning often hits the same place twice? It's not luck, it's physics. Tall objects, metal structures, open fields. They shape the path, not by force, but by invitation. And the air in between, once thought to be empty space, it is now seen as a dynamic field, a barrier that sometimes holds, sometimes gives. It's easy to forget how fragile air really is. We move through it as if it were nothing. But when electricity charges through it, air reveals itself to be very much something, a medium that can burn, expand, even scream. That scream becomes thunder, and thunder in turn becomes a map of the storm's inner world. Lightning doesn't only occur during storms. It has been recorded in volcanic eruptions, nuclear explosions, even in the ash plumes of wildfires. Any place where particles rub, separate, and discharge, lightning can form. Even on other planets, lightning crackles through the skies of Jupiter and Saturn, illuminating alien clouds in massive bursts. On Venus, it dances inside sulfuric storms. On Earth, it feels personal, but it is universal. The most dangerous kind of lightning isn't the brightest, it's the one you don't see coming. Positive lightning, less common but far more powerful, can shoot out from the top of a cloud and strike the ground over 20 kilometers away, even under clear blue sky. These bolts can carry 10 times the energy of a regular strike, often catching people off guard in places where the storm hasn't yet arrived. This is why we're told to seek shelter not when the rain begins, but when the first distant rumbles of thunder are heard. If you can hear thunder, you are within range of lightning. The storm has already extended its reach to you. There's a reason we feel electricity before we see it. The hair on your arms stands up. Your breath shortens. There's a charge in the air, not metaphorical, but real. The electric field around you is shifting, and your body knows before your eyes do. Birds change course. Deer freeze. Dogs whimper. The natural world has evolved to read storms before they break. And yet, even with all our instruments, sometimes we don't know a bolt has struck until the power goes out or the sirens start. Lightning is more than weather. It's a consequence, a system resetting itself. In moments, it can split trees, ignite fires, vaporize sand into glass. It can stop a human heart in mid-beat. It can dance across the surface of a lake or strike a golf course under a blue sky. But despite its danger, we remain captivated by it, not just for its violence, but for its beauty. That flash across the horizon, that raw, unpredictable fork in the night, the way it lights the world for a single burning instant. There's something humbling about knowing we still cannot control it. We can map it, we can measure it, but we cannot stop it. And maybe that's why we listen so closely to the thunder that followed, because we know deep down that it came from something we do not command.
Chapter 3. The Language of Thunder. How Sound Reveals the Storm's Secrets. There's a moment, just after the lightning fades, when the sound begins to speak. Not in words, but in texture, in distance, in rhythm. The thunder doesn't just roll, it communicates. Most people hear thunder and think it's just noise. But what we call noise is often just sound we haven't learned how to listen to. And thunder is a kind of language. The storm is telling us where it is, how large it's become, how far its reach extends. If you know how to listen, you can hear the anatomy of the storm in every low boom and high crackle. You can feel its power before it reaches you. Sometimes you can feel it inside your bones. When lightning flashes, it doesn't just create one sound. The entire length of that bolt, sometimes stretching across 5, 10, even 20 kilometers, ignites the air all at once. But the sound doesn't arrive in one clean burst. It travels, scattered and reshaped by everything in its path. Some waves bounce off mountaintops, some wrap around trees and buildings. Others are swallowed by the wind or warped by the temperature gradients of the atmosphere. It's why thunder often arrives in pieces. First, a sharp, crackling snap like a bone breaking in the sky. Then a low, expanding roar that seems to roll for ages. Then a tail end, distant and soft, echoing like a final exhale. No two thunderclaps are identical, because no two bolts follow the same path, and no two journeys through the air are ever quite alike. Even the pitch of thunder holds clues. A high-pitched crack suggests a short, nearby bolt, the air breaking just overhead. A deep, booming rumble that seems to shake the floorboards likely comes from a massive discharge further away, filtered and softened by layers of atmosphere. If thunder sounds sharp and metallic, it may have bounced off something, a building, a cliffside, even a canyon wall. If it sounds muffled or distant, it may have been absorbed by foliage, hills or heavy rain. The delay between lightning and thunder isn't just for dramatic effect. It's a map. Count the seconds between the flash and the boom. Divide by 3. That's how far away the strike occurred, in kilometers. Each second of silence is space, and space gives sound time to stretch, to lose sharpness, to melt into something rounder and slower. The further the bolt, the smoother the thunder becomes. This is how humans have been tracking storms long before we had satellites or radar. On an open field or from a cabin window, counting that delay has always been a way of measuring not just distance, but danger. 1 second, 2, 3, you breathe easy. But when the flash and the roar arrive together, your instincts don't need math to tell you you're inside the storm now. But thunder does more than warn. It reflects. It reveals the condition of the air itself. In dry air, thunder sounds brittle, clearer, more direct. In humid air, it sounds thicker, heavier, almost sleepy. That's because sound travels differently depending on moisture, temperature and pressure. Scientists call it atmospheric acoustics. But to you and me, it's just how the sky feels when it speaks. The sound of thunder over water is another kind of experience. On a still lake or the open ocean, thunder spreads like ripple. It can be heard miles from the storm's core, clean and uninterrupted. Fishermen tell stories of hearing thunder from storms that don't arrive for another hour, and sometimes never arrive at all. But the sound reached them. Because water doesn't just reflect lightning in silver flashes, it carries sound like a drumhead stretched across the world. In valleys, thunder gets trapped. It echoes between slopes, repeating itself like a ghost caught in a loop. In cities, it ricochets between skyscrapers, sometimes creating the illusion of thunder coming from every direction at once. In deserts, it travels in long, pure lines, dry, sharp, ancient. On flat plains, it rolls like a train in the distance. On snow, it's softened, absorbed, like the sky whispering instead of shouting. This variability makes thunder one of the most complex natural sounds we encounter, and yet it's one of the least studied. Why? Because it's difficult to reproduce in a lab. It's unpredictable,
uncontrollable. It happens when nature decides. And even then, no two thunder events behave the same way. But scientists are beginning to harness thunder in new ways, not just to analyze storms, but to understand the sky's behavior as a whole. With sensitive microphones and high-speed audio processing, researchers can now study the structure of a thunderclap. They can isolate different frequencies, measure how sound intensity varies across time, and model how different parts of a lightning bolt contribute to different parts of the thunder. These studies have shown that thunder is rich in low-frequency energy, the kind that travels long distances and shakes buildings. These low frequencies, known as infrasound, are often felt more than heard. They make your chest vibrate. They stir the air in your ear. Some frequencies are so low, they sit below the threshold of human hearing, yet they move through our bodies all the same. Animals pick them up long before we do. That's why birds scatter before storms, why dogs begin to whimper, why herds of animals sometimes move in coordination hours before we see the first flash. They're listening to something we can't hear, but definitely feel. And in that sense, thunder is not just a product of a storm, it's a message, a system of signals sent out in every direction, announcing the storm's presence, its energy, its movement. Some scientists believe we'll soon be able to use thunder itself, its frequency patterns, volume shifts, and timing to estimate storm severity, track lightning without visual confirmation, or even model how climate change is altering the upper layers of the atmosphere. In that vision, thunder isn't background noise, it's data. Live raw acoustic data from the sky. But you don't need a lab to feel thunder's complexity. You've felt it already. That moment at night, lying in bed with the lights off, when the whole room seems to vibrate from a strike 5 miles away. The slow, distant growl that moves across the sky like it's rolling toward you on invisible wheels. The split-second jolt when thunder cracks so close it feels like it came from inside your own house. Thunder interacts with the body in a way few sounds do. It activates our startle reflex. It can increase cortisol, trigger memories, or make the hair on your neck stand up. It doesn't matter how many times you hear it. When it's close, it always gets a reaction. And maybe that's part of the reason it's been mythologized for so long. To ancient cultures, thunder wasn't just a sound, it was a voice, a warning, a god's presence, or a guardian spirit watching over the land. And even though we now explain it with thermodynamics, shock waves and plasma physics, the feeling remains, that awe, that tremble, that sense that something larger than us is moving through the sky. In a world that feels increasingly artificial, filled with machines, algorithms and constant noise, thunder remains one of the last natural sounds that still silences us. It stops conversations, it quiets streets, it pulls our eyes to the sky, where no screen can compete with the simple power of a flash and the rumble that follows. And in those moments when the sound wraps around you and you realize the storm is no longer far away, you listen, not just to what it is, but to what it's saying. Because sometimes the sky doesn't speak in sunlight. Sometimes the sky speaks in thunder.
Chapter 4. How Thunderstorms Form. The Anatomy of Skyborne Violence. It begins in silence. A warm breeze, a rising current of air. Clouds gather, lazy and soft at first, like paps of breath on a mirror. There is no thunder yet, no flicker of light, just rising heat, unnoticed. But deep inside that gentle updraft, a transformation is beginning. The sky is building something, a tower, a machine, a storm. For a thunderstorm to form, 3 key ingredients must come together: moisture, instability and lift. It sounds simple, almost harmless, but when these elements align just right, they create one of the most dynamic engines of power in the natural world, a system capable of shaking the earth, flooding cities, and tearing the sky open with fire and sound. It starts at the surface. Warm, moist air near the ground begins to rise. Maybe it's been heated by the sun all morning. Maybe a cold front has pushed under it, lifting it like a shelf. Or the way that air begins its journey upward. As it rises, the air cools, and when moist air cools, water vapor condenses into tiny droplets, forming clouds. But it's not just cloud formation. It's a chain reaction. The process of condensation releases latent heat, a hidden form of energy that supercharges the rising air, making it even warmer than its surroundings. This creates more lift, more rising, more condensation. The column builds higher and higher, feeding on itself, growing into a massive vertical structure that can reach the height of commercial airliners. This is the birth of a cumulonimbus cloud, the storm cloud. It doesn't drift like other clouds. It climbs. It roars upward through layers of the atmosphere, dragging heat and moisture into the sky. From below it looks like a towering anvil, its top flattened by the edge of the stratosphere. Inside it is alive with motion, air rushing upward at speeds that can exceed 1 kilometers per hour, pulling droplets, dust, ice and hail into a wild vertical carousel. It is within this roiling column that thunder is born, but not yet. First, the storm must sort itself. As the air rises, it cools further, freezing the upper regions of the cloud into a swirl of ice crystals and supercooled water droplets. These frozen particles crash into each other, creating friction and breaking apart electrons, the foundation of electrical charge. The storm becomes polarized. Positive charge builds at the top. Negative charge settles near the bottom. The ground below, feeling the pull, begins to accumulate positive charge as well, creating an invisible tension between earth and sky. The stage is set. Lightning will come, thunder will follow. But the storm is more than just a lightning factory. It is an atmospheric engine, converting heat and moisture into kinetic energy. As the rising currents hit the upper boundary of the troposphere, they can go no higher. The air flattens out into a massive, cold canopy that can stretch for kilometers. This is the anvil. It often points in the direction the storm is moving, like the prow of a ship slicing forward through invisible seas. And then, everything begins to fall. The upper layers, cooled by altitude and precipitation, grow heavy. Raindrops collide, merge and become too massive to stay aloft. Hailstones form, tossed up and down through the cloud's interior like coins in a fountain. Eventually gravity wins. Rain begins to fall in thick, cold sheets, and with the rain comes downdrafts, columns of sinking air that push outward when they hit the ground, creating gusty winds, temperature drops, and sudden pressure changes. If you've ever felt that eerie shift before a storm, a gust of cold wind sweeping under a darkening sky, you were feeling the downdraft, a whisper of the force about to arrive. Some thunderstorms stay small. They blossom and vanish in under an hour, watering fields and refreshing dry cities. Others become vast systems, merging into squall lines or supercells, long-lived, rotating giants capable of spawning tornadoes, unleashing flooding rains, and hurling hailstones the size of fists. These storms can stretch across entire states, marching forward with precision, each cell feeding the next, like gears in a colossal moving machine. Inside these beasts, lightning dances like nervous energy, dozens of strikes per minute, both inside the cloud and toward the earth. Every flash is a release. Every thunderclap is a symptom of the system trying to regulate itself. And in the heart of it all, the air is electric, literally. But no matter how complex the storm becomes, it all comes back to that original trio: moisture, instability, lift. Without them, the engine fails, the clouds drift apart, the heat disperses, the sky breathes out and returns to calm. Yet when they align again, and they always do, the process restarts. The earth is never still, its oceans are never dry, its atmosphere is never perfectly balanced. Thunderstorms are not rare events. At any given moment, there are over 2,000 thunderstorms happening around the planet, over 40,000 lightning strikes every minute.
It's not chaos, it's rhythm. The planet exhales, the sky responds. Thunder is not the exception, it's the sound of the world functioning. Some regions experience more of it than others. The tropics, with their constant heat and moisture, are storm factories. Central Africa, parts of Southeast Asia, northern South America. These areas see hundreds of storms a year. In the United States, Tornado Alley carves a seasonal path through the Central Plains, where dry air from the Rockies meets warm Gulf moisture and triggers epic storms. But even in quiet corners of the world, the pattern persists. A warm day, rising heat, a thickening of the air, a slow climb upward into sky, and then, when the tension becomes too great, a flash, a sound, a storm. Thunderstorms are not just weather events, they're systems of transformation. They take moisture and turn it into energy. They take imbalance and turn it into motion. They take silence and break it with the voice of the planet itself. When we hear thunder, we are hearing the final product of thousands of invisible interactions. Every crash is backed by millions of water droplets, colliding, condensing, freezing, falling. Every rumble carries the weight of a towering cloud that built itself from nothing but air and sunlight. Every strike of lightning is the consequence of particles rubbing together in the upper sky, of imbalance seeking correction in the most violent way possible. And yet when the storm passes, it leaves behind a kind of clarity. The air feels different, clean, cooled, as if something has been reset. Maybe it has. Maybe that's why thunderstorms, for all their violence, feel oddly personal, as if they're not just attacking the landscape but shaking something loose in us too. A reminder that we are not in control, that we are smaller than we think, that above our roofs and schedules and plans, the sky has its own agenda, and that sometimes all it takes is a little heat, a little moisture, and a little lift to make the sky roar.
Chapter 5. The Sky Cracks Open. Why thunder sounds the way it does. It doesn't just start with a boom. It starts with a split, a sudden rupture in the invisible, a tearing of the air so violent, so instantaneous that it creates a pressure wave capable of shaking the ground, rattling your windows, and making your breath catch in your throat. Thunder is not sound the way we usually think of it. It's not a voice. It's not an echo. It is the aftershock of the sky itself being ripped apart. When lightning streaks through the atmosphere, it does so with unimaginable speed and force. In under 1,000th of a second, a bolt can superheat the surrounding air to over 30,000 degrees Celsius. That's 5 times hotter than the surface of the sun. The air, once a silent cushion between earth and cloud, cannot expand fast enough to handle the sudden energy. It doesn't stretch, it detonates. The shockwave this creates travels outward in all directions. It moves as a wall of compressed air, raw, unfiltered pressure tearing through space. That's what you hear when thunder explodes above you. You're not hearing the lightning itself, you're hearing the atmosphere's response to it. A reaction so intense that it creates a sound capable of traveling miles. A sound that doesn't just reach your ears, it moves through your body. You feel it in your chest, you feel it in the soles of your feet. But why does it sound the way it does? Why does one strike crack like a whip, while another rolls like distant drums? The answer lies in the structure of the lightning and the space it moves through. Lightning is not a simple line. It forks, zigzags, and branches, often spanning kilometers. Every twist, every turn, every branch becomes a separate origin point for sound. Each section of the bolt expands the air around it, sending its own wave of thunder outward. What you hear is the sum total of those waves arriving at your position. Some fast, some slow, some sharp, some diffused by terrain or wind or humidity. That's why thunder often arrives in phases. First, a loud, crisp snap. This is the near-field shock wave, the part of the bolt closest to you, whose pressure wave hasn't had time to stretch out. Then comes the roll, the deeper, more distant sound that follows as the shock waves from farther sections of the bolt reach your ears, scattered and softened by the journey. If you're near a strike, the thunder can be deafening, sharp, almost metallic. If the strike is far, it rumbles like a freight train miles away. But even that distant growl carries power. It speaks of something immense, something moving in the sky above, just beyond your reach. Temperature and atmospheric layers also shape the sound. On a hot, dry day, sound travels differently than on a cold, humid night. High humidity makes the air denser, which can cause thunder to carry further, but also dull its sharpness. Cold air can bend sound waves downward, making thunder seem closer or more dramatic. Wind can scatter sound or focus it, causing strange directional effects, sometimes making thunder seem like it's coming from behind you when the strike was far ahead. Even your location matters. In a forest, thunder sounds muffled. Trees absorb and scatter the sound, turning sharp cracks into hollow murmurs. In a canyon, thunder bounces and repeats, stacking on itself, echoing like 100 drums in the dark. In the city, it can ricochet between skyscrapers, sounding fractured, like the storm is everywhere at once. Over water, it becomes clear and haunting, rolling across lakes and seas with eerie precision, uninterrupted by land or walls. But there's something else, something deeper. Thunder often carries infrasound, frequencies below the threshold of human hearing. We can't detect them with our ears, but we feel them. These low frequencies travel long distances, wrapping around obstacles that would block higher-pitched sounds. They penetrate buildings. They vibrate through the ground. They can be measured even when the thunder itself seems too far away to hear. Infrasound from thunder is used in atmospheric studies. Scientists track these frequencies to monitor distant storms, even nuclear tests, using infrasound as a sort of global. But animals, it turns out, were the first to use it. Birds, elephants, whales, all creatures that rely on long-distance sound to communicate or navigate, respond to distant thunder in ways that suggests they can sense what we cannot. Some animals flee before storms even appear on the radar. They know. Somehow they always know. And perhaps it's because they're listening to a part of thunder we've forgotten how to hear. There's also the strange phenomenon of rolling thunder, that slow, seemingly endless rumble that moves across the sky like a wave. It doesn't arrive all at once. It flows. This isn't just echo. It's an acoustic tapestry woven by multiple lightning segments, each spaced out just enough for their sounds to arrive one after another. The result is thunder that doesn't crash, but unfold. Some of the most dramatic rolling thunder comes from cloud-to-cloud lightning, where bolts stretch horizontally across the sky. These horizontal bolts can travel for tens of kilometers, each segment producing its own thunder. Because of the distance between the segments and your position on the ground, the sound reaches you like a domino effect, first from the closest branch, then from the next, then the next, until it feels like the entire sky is moving. And then there's positive lightning, a rarer, more dangerous form of discharge that originates from the top of the storm cloud and can strike up to 20 kilometers away. Positive lightning carries more energy than typical strikes, and often produces louder, longer-lasting thunder. When you hear a thunderclap that shakes the walls, long after the flash has disappeared from sight, there's a good chance it was one of these. Even though thunder is chaotic, it's governed by physics. Sound waves travel in predictable ways. They reflect, refract, interfere. But the sheer number of variables in the sky, humidity, temperature layers, wind speed, terrain, makes thunder one of the most unpredictable natural sounds we encounter. No two storms produce the same thunder. And even within a single storm, no two rumbles are alike. Still, there is pattern, a kind of acoustic signature. Scientists are now developing ways to model these sounds, to reverse engineer the lightning bolt just from the thunder it produces. Imagine that, listening to thunder and seeing the bolt it came from, without ever having witnessed the flash, turning sound into vision, data into geometry. It's already begun.
With high-speed microphones and pressure sensors, researchers can reconstruct the path, shape and energy of lightning events by analyzing the thunder that follows. They can isolate where the bolt originated, how long it was, even whether it split or twisted during its journey. In essence, they're learning to read thunder, not as noise, but as a message. And maybe that's what it's always. When thunder rolls over a sleeping city, when it echoes across an empty field, when it shudders through your walls and into your chest, it's not just the sky reacting. It's the sky reporting, telling you what just happened, what forces just clashed, what energy just exploded. It doesn't ask for attention. It demands it. You can't ignore thunder. You can't tune it out. It cuts through everything. Music, conversation, silence. It doesn't matter if you're indoors or out. It finds you. And perhaps that's the point. In a world full of alerts and notifications and artificial noise, thunder is the one sound we still respect. It stops us. It pulls us to the window. It makes us count seconds. It makes us wonder how close it really was. It makes us remember that above our structured lives, there is still wildness. There is still power we do not control. There is still something out there with the ability to speak, not in words but in force. Because when thunder cracks, it is not asking a question. It is giving an answer.
Chapter 6. What the eyes don't see. Thunder's invisible connection to light. Before the thunder ever comes, the sky flashes. It's instinct now to look up the moment a room lights up. No matter how far away the storm is, no matter how faint the glow behind the clouds, our eyes notice. Lightning commands vision. It is fast, brilliant, impossible to ignore. But the thing we often forget is this. Lightning is not just something we see. It's also something that reveals how little we actually do. Our eyes are tuned to a narrow sliver of the electromagnetic spectrum, a small window of visible light, ranging from violet to red. But lightning emits far more than what we can perceive. It bursts across the spectrum, radiating in ultraviolet, infrared, radio waves, X-rays, even gamma rays. The flash we see is only a fraction of what truly happened. And yet it's enough to stop us in our tracks. For that one moment, the world is illuminated, not gently, like sunrise or candlelight, but violently, like a truth too sharp to handle. Shadows vanish. Silhouettes sharpen. Everything is revealed, just for a blink, and then it's gone. It's as if the universe opened its eyes just long enough to remind us it was watching. But the connection between lightning and sight goes deeper than that. When a bolt explodes across the sky, it triggers more than a visual response. Our pupils contract, our retinas burn the image. The brain fires off alerts before we've even had time to think. Lightning isn't processed like other sources of light. It arrives too fast, too sudden. By the time you realize you saw it, it's already burned its impression into your memory. It's no accident that we describe realizations as flashes, that something dawned on us, that we had a light bulb moment. Lightning is the language of sudden understanding, and thunder is the reminder that understanding comes with consequences. What we see is only the surface, but what we feel, what we hear, that's the depth. Still, the human eye is extraordinary. In complete darkness, after minutes of adjustment, it can detect a single photon. That means during a distant thunderstorm, even if the lightning is miles away, your eyes are catching light particles that traveled through thick clouds, bouncing off raindrops, diffused across the atmosphere, and still manage to reach your retina. That's the power of light, and lightning at its core is raw, uncontrolled light in motion. But it also plays tricks on us. Have you ever seen a lightning flash and waited, but no thunder came? That's called heat lightning. It's not a different kind of lightning, but a trick of distance and timing. You saw the flash. It was real. But the thunder, traveling much slower than light, was too distant or too scattered to reach your ears. The storm may have been over 20 kilometers away, beyond the sound horizon. Your eyes detected something your ears could not. And sometimes it's the opposite. Thunder arrives without warning. A sharp clap, a sudden boom, and you never saw the flash that caused it. That's because lightning doesn't always strike in open view. It can remain hidden behind clouds, veiled by rain, or flash horizontally across the sky outside your field of vision. The light might scatter, fade, or get blocked, but the sound will still come. That disconnect between what we see and what we hear is more than a delay. It's a revelation about the way our senses interpret reality. Lightning is nearly instantaneous. Thunder takes time, but both come from the same event. One is visual, the other is physical. And the gap between them, that silence between flash and boom, tells a story. It tells you how far away danger is. It lets you count seconds. It lets you measure the sky. There's something poetic about that. That sight comes before sound. That realization comes before consequence. That a sudden burst of light announces the energy, and then the atmosphere answers. But the light we see is not the only light that exists. Lightning produces ultraviolet radiation, which some animals can see even when we cannot. Bees, birds, and certain insects perceive patterns in UV light, invisible to us. In a way, they see storms different. What we experience as bright white flashes, they might see as shimmering bursts of hidden color, flickering through their world like messages in a code we've lost the ability to read. Lightning also produces X-rays and gamma rays, two forms of light so energetic they can penetrate matter. These bursts, invisible to the human eye, are detectable by satellites orbiting far above us. Astronomers have long studied terrestrial gamma-ray flashes, strange, brief emissions of high-energy radiation that accompany some of the strongest lightning bolts. For a long time, scientists thought gamma rays only came from deep space, from black holes and neutron stars. But it turns out, sometimes they come from our own sky. That should humble us, because it means that right here, in the clouds above your neighborhood, the kind of energy usually reserved for the collapse of dying stars is crackling into existence for a fraction of a second. Just long enough to be noticed, then gone. But even the visible light, the part we can see, is more complicated than it seems. Lightning is not a single flash. It's usually a series of rapid strokes, each tracing the same path milliseconds apart. Your eyes can't separate. The result appears as one flickering, trembling bolt, but it's really a sequence, a strobe of destruction. And that's why the light looks so alive, why it seems to move, why it flickers even when it's a straight line. Your eyes are catching multiple events happening so quickly they blur into one, each pulse lighting the world again from a slightly different angle. It's no wonder we stare. Lightning commands the gaze in a way few natural phenomena can. We're drawn to it, hypnotized even when we're afraid. Some people chase storms just to see it, not just for the thrill, but for the vision. That instant of clarity, that moment when the world is lit from within, when the landscape glows in sharp relief, when the night becomes day, just for a breath. Photographers try to capture it, but lightning doesn't pose. It doesn't wait. You can't predict its exact path. You can't plan the frame. You have to watch over and over with patience and reverence. And when the camera shutter opens at the right moment, when the sky cracks open and your lens catches it, it feels like you've stolen fire from the gods, because lightning is visual poetry. But thunder is punctuation. Thunder says, "You saw that, now feel it." And so our eyes take in what they can. They record the blaze, they blink against the brilliance, but they will never see all of it. They were never meant to. Much of the lightning story lives outside our range, beyond what rods and cones can decode. Yet still, every time it happens, we turn to the window, we scan the clouds, we wait.
because even in a world of artificial lights and endless screens, we still respond to that ancient primal flash in the sky. It bypasses technology, it bypasses thought, it goes straight to You may not hear the thunder yet, but you saw the message, and something in you, something deeper than reason, is listening.
Chapter 7. Chasing Thunder. The science and danger of lightning strikes. It strikes without warning. 1 second, you're standing in the calm before the storm. No rain, no wind, just heavy air and the strange silence that follows a long exhale from the sky. Then, a flash. A crack so sharp, it feels like the air split in half. The hairs on your arm stand up, your breath freezes, and everything in your body seems to pause. You don't think, you react. Because lightning isn't just light, it's a predator. And when it strikes, thunder follows like an echo of judgment. Lightning doesn't announce itself in words. It arrives with a force measured in millions of volts and thousands of degrees. Each bolt carries enough electricity to light a city block. But more than energy, it carries consequence. In less than a second, it can kill a tree, melt a telephone pole, knock out a power grid, or stop a human heart. And yet it remains one of the most mesmerizing things we've ever seen. Maybe that's why we chase it. Storm chasers, scientists, photographers, and thrill seekers all head toward the danger. They drive straight into the places others flee from, all for the chance to witness the raw mechanics of the sky up close. Not to tame it, but to study it, to feel it, to know it better. To chase lightning is to accept that you will never truly control it. The goal isn't conquest, it's understanding. And there's so much we still don't understand. Why does lightning strike one tree but not the other? Why do some storms produce dozens of strikes per minute, while others release only a few? Why does lightning sometimes seem to climb upward into space rather than downward to Earth? We know the conditions that create lightning: charged particles, colliding water droplets, polarized clouds. But predicting the exact moment, the exact target, still eludes us. It's not like forecasting rain or temperature. Lightning is a decision the sky makes, and it doesn't explain itself. But what we can do is measure what happens after. When a bolt of lightning strikes the ground, it follows the path of least resistance. That might be a metal pole, a tree, or a human body. The current surges through, sometimes exiting in explosive ways. Trees can burst open as sap rapidly vaporizes into steam. Concrete can spall, cracking and flying outward. Soil can fuse into fulgurite, a rare glass formed by the intense heat of a strike traveling through sand. And if it passes through a person, the results can be both devastating and bizarre. Lightning strikes can cause cardiac arrest, severe burns, nervous system damage, and memory loss. But some survivors walk away with scars shaped like branches, fractal patterns called Lichtenberg figures, burned into their skin, like lightning's signature, left behind. These intricate marks trace the paths where electricity traveled through tissue. They are beautiful, painful reminders of something most don't live to describe. There are people who have been struck more than once. The most famous, a park ranger named Roy Sullivan, survived 7 lightning strikes in his lifetime. Each one left a scar, a story, and the lingering sense that lightning somehow knew him. That's not science, but it's how it feels. Because lightning often seems like it chooses, but the truth is, it follows the physics. It's drawn to tall objects, sharp edges, conductive materials, a metal fence, a flagpole, a lone tree in a field, and sometimes, tragically, the tallest thing in the landscape is a person. Being in an open area during a storm is one of the most dangerous places you can be. That's why the rule exists. When thunder roars, go indoors. It may sound like a slogan, but it's rooted in fact. If you can hear thunder,
you're within striking distance. The storm doesn't need to be overhead to reach you. Lightning can arc across miles of sky. Some bolts stretch horizontally before dropping down. Others strike before the storm arrives or after it's passed. There's even positive lightning which originates from the tops of clouds. These rare bolts are more powerful, more dangerous, and can travel farther than typical negative strikes. They are less common, but far more deadly, often delivering up to 10 times the energy of a normal bolt. In this complexity, researchers have developed tools to study lightning in new ways. High-speed cameras now capture lightning at hundreds of thousands of frames per second. These videos reveal that what we see as a flash is actually a dance, a chaotic flicker of branching filaments, searching for connection. Slow it down, and you'll see the stepped leader reaching downward, pausing, changing direction, feeling its way through the atmosphere. Then the return stroke explodes upward, blazing a path back through the same channel. This exchange happens so fast, our eyes see only the final burst. But cameras don't blink, and now, neither do we. There are even systems to trigger lightning, on purpose. In places like Florida and New Mexico, researchers launch small rockets trailing grounded wires into storm clouds, inducing lightning strikes in controlled settings. These experiments help us understand the physics, improve lightning protection systems, and gather data that would be impossible to collect from natural strikes alone. Still, lightning refuses to be entirely tamed. It bends around rules. It surprises experts. It leaps across the sky in ways we didn't expect. And every once in a while it teaches humility by taking out a power station, or igniting a wildfire, or striking a person where no strike should have reached. It's a reminder that science is not about controlling nature. It's about learning how to coexist with it. We've developed lightning rods, grounding systems, surge protectors, all designed to redirect or absorb the force of a strike. Skyscrapers are built with lightning in mind. Planes are struck regularly and continue flying because they're designed to handle the current. But still, homes burn, lives are lost, systems fail, and thunder keeps rolling. The pursuit of lightning knowledge has also taken us upward, not just to storm clouds, but beyond them. Above the thunder clouds, in the cold reaches of the upper atmosphere, strange events occur. Sprites, elves, and blue jets, exotic types of lightning that flicker not downward, but up toward space. These ghostly glows were once dismissed as pilots' hallucination. Now they are studied with satellites and high-altitude observatories. Sprites are enormous bursts of red light that shoot above storms like jellyfish-shaped pulses. Blue jets fire narrow beams upward from cloud tops. Elves appear as rapid expanding disks of light in the ionosphere. All of these phenomena are linked to powerful lightning events, their existence proof that a single strike on Earth can affect the upper reaches of our atmosphere. So when you hear thunder, remember, the bolt that caused it might have reached into space, shaping magnetic fields, triggering radiation bursts, even sending particles spiraling through the atmosphere. A single flash of light, a single thunderclap, echoes far beyond the cloud you can see. And that's what makes lightning so compelling. It connects. It links the earth to the sky, the present to the ancient, the visible to the invisible. It reminds us that power doesn't always announce itself gently. Sometimes it arrives in silence, then explodes with sound. So we chase it, not just with wheels and cameras, but with questions. We ask what it means, where it goes, what it touches on the way down, and what it leaves behind when it vanishes. We ask because somewhere inside, we know that when thunder shakes the world, we're being told a story that begins not in the clouds, but in the imbalance between things, in the friction between layers, in the quiet tension of a world waiting to release its charge. And when that release finally comes, it doesn't whisper, it roars.
Chapter 8: Storms That Breathe. The life cycle of thunderclouds. It starts like breath, a rising swell of air, slow and invisible, moving upward from the warmth of the earth. At first you'd never notice it. The trees don't bend. The sky looks calm, but far above. Molecules are gathering, circling, swelling, pushing against the weight of the atmosphere. The storm is not born in violence. It's born in silence, in the subtle lift of moisture, the invisible stretching of space, where pressure drops and clouds begin to form. This is how all thunderstorms begin. Not with thunder, not with lightning, but with motion. Warm, humid air at the surface begins to rise. Sometimes the trigger is the sun's heat on a field or a stretch of road. Sometimes it's a cold front forcing warm air upward. Sometimes it's the gentle curve of a mountain slope, nudging the air to climb. Once the ascent begins, everything changes. As the warm air lifts, it expands and cools. Water vapor condenses into droplets. The energy locked inside that vapor is released as heat, and that heat gives the rising air more power. It's a self-feeding engine, rising, condensing, heating, rising again. This process builds the clouds we see, not the soft, slow kind that drift across a spring sky. No, this is vertical development. Clouds that don't wander, they climb. Towering cumulus grows into cumulonimbus, the anvil-top giants of the atmosphere. They rise with force, piercing the sky, stretching through the troposphere until they slam against the ceiling of the stratosphere and flatten out like a hand pressing into glass. And still they grow. Inside these clouds, air rushes upward at speeds that rival hurricane. Raindrops form and are thrown higher. Hailstones grow layer by layer as they ride this updraft elevator. Ice crystals slam into droplets. Collisions rip electrons free. Positive and negative charges separate, stacking like opposing armies within the same cloud. The air itself becomes a battery, fully charged, waiting for discharge. The storm has reached maturity. At this point, the thundercloud becomes a creature all its own, breathing in heat and moisture, exhaling rain, wind, and sound. The updraft at its core is balanced by downdrafts created as rain and hail begin to fall. Cold air descends with the precipitation, spreading outward at the ground like a shockwave, chilling the air beneath the cloud and triggering gusts that slam windows and scatter debris. This is when we feel it most. The sudden wind, the darkness at noon, the quiet that creeps in just before the sky breaks. The moment you step outside and the world feels different, like you're standing in the lungs of something alive. A storm about to exhale. Then comes the rain. It doesn't fall gently. It lashes. Thick drops strike the ground in rapid succession. If there's hail, it arrives like teeth. Round, hard, frozen bites of the upper sky crashing down. The lightning flashes more frequently now, strobing inside the cloud, illuminating the rising and falling currents like the gears of a machine. With each flash comes the promise of thunder. With each roar, the storm announces itself. If the conditions are right, rotation may begin. A subtle twist in the updraft that spirals into a mesocyclone, the precursor to tornadic activity. Supercell thunderstorms, the most violent type, can sustain themselves for hours, traveling across entire regions, growing, evolving, producing wave after wave of rain, hail, and lightning. But no matter how powerful, every thunderstorm is temporary. Even the fiercest giants fade. Eventually, the downdraft becomes dominant. The cold air falling through the cloud chokes the rising current that once fed it. The storm begins to collapse under its own weight. Lightning becomes less frequent. The thunder softens. The rain tapers off. The anvil top frays and dissolves. What once towered with fury now scatters into mist and memory. And the sky, for all its rage, returns to calm. This is the life cycle of a thunderstorm. A birth, a bloom, a breath, and a stillness.
A system that takes heat and gives it shape, a process that brings energy from the ground to the heavens and back again. But every stage leaves its mark. The ground is soaked. The air smells of ozone. Puddles ripple where hailstones melted. Trees sway gently, unsure whether the wind is truly done. And somewhere above, at the edge of vision, new clouds begin to rise, drawn upward by the same forces, following the same invisible script. Because the cycle is never truly over. The earth is always warming. The air is always rising. The atmosphere is always looking for balance, and in that search, it creates storms. Sometimes brief and beautiful, sometimes monstrous and merciless, but always meaningful. To watch a thunderstorm is to watch the planet adjusting itself. Thunder is not a mistake. Lightning is not a malfunction. These are the systems of nature, primal, precise, necessary. They cool the air. They redistribute moisture. They crack nitrogen molecules that fertilize the soil. They shake the dust from the sky. They keep things moving. And yet, we fear them. Or maybe more truthfully, we respect them, because a storm is one of the few things we still step back for. We close windows. We delay plans. We pause conversations. Something ancient in us still knows when the sky speaks in thunder. It's wise to listen. We talk about storms as if they are angry, as if they rage or punish. But storms don't feel. They don't seek. They respond to imbalance, to energy, to the fundamental physics of the air. But that doesn't mean they aren't expressive. There is poetry in their pattern. There is rhythm in their rise and fall. There is truth in the way the sky turns dark and then, hours later, opens back up to let the sun through again. It's as if the storm was never there, and yet the ground is wet, the trees glisten, and your heart is still beating a little faster than before. The storm touched you, and you know it. So the next time you watch those clouds rise, the next time you hear thunder and see the flash, remember what you're witnessing. Not just a weather event, not just a threat. You are watching the sky breathe, taking in what the earth gives, and returning it with force. This is what thunder comes from. Not rage, but balance.
Chapter 9. The Sound of Distance. How thunder tells you where the storm is. It begins with a flash, sharp, unmistakable, a jagged tear in the sky. Then comes the wait. You stand still, ears tuned to silence, counting without even thinking about it. One, and then, finally, the boom. Low, steady, growing and fading like the breath of something vast. You don't need instruments. You don't need technology. That space between lightning and thunder is the oldest weather tool known to humanity. It's how we measure distance with our bodies. Every second of silence is a clue. The lightning has already happened. The light reached you almost instantly. Nothing on earth travels faster, but thunder is slower. It takes time to arrive. So you listen. 1 second equals about 40 meters. 3 seconds. The strike was a kilometer away. 5? More than a mile. You can feel the storm's approach in the shortening gaps between flash and sound, like footsteps getting closer. It's a strange feeling, knowing that something so violent is moving toward you, and yet having the ability to sense it just by counting. No radar, no forecast. Just light, time, and your own awareness. The sky in that moment becomes a kind of clock, and thunder is the ticking hand. But distance is not the only thing it tells you. There are subtler signals hiding in the sound. The sharpness of the initial crack, the length of the roll, the way the thunder echoes or fades. Each of these reveals something about the storm's shape, its energy, and even the path of the lightning bolt itself. A crisp, short burst of thunder suggests the bolt struck nearby. The shockwave reached you before it had time to stretch out, to scatter. A rolling, drawn-out rumble means the lightning was farther away, and probably longer in shape, arcing across the sky, with each segment of the bolt creating its own pocket of sound. The thunder you hear is not one sound, it is a chorus, each voice delayed by its distance from you, blending into a single sustained note that dances through the air. And the direction, that's trickier. Thunder is a pressure wave. It expands outward in all directions from the bolt, not just forward like a voice or music, but in a sphere. It wraps around buildings, bounces off hillsides, and bends with the wind. By the time it reaches your ears, it has been shaped by the landscape. If you're in a valley, it may echo. If you're in a city, it may seem to come from everywhere at once. In an open field, you may be able to tell the general direction. But the sky is a master of disguise. Thunder doesn't always sound like it's coming from where the lightning was. Even wind can bend it. Strong upper-level winds can refract sound waves downward, allowing you to hear thunder from much farther away than usual. At other times, the wind carries the thunder away, leaving you in silence, even though lightning flashed just miles from where you stand. This is why thunderstorms can feel so uneven. Why a strike might light up your entire window and yet arrive in silence. Why sometimes the rumble lasts for 30 seconds and sometimes it seems to vanish in an instant. You are not just hearing the storm, you are hearing the space between you and the storm. And that space is full of story. It matters what time of day it is. At night, when the air cools and settles, thunder travels far. The atmosphere becomes layered, cold air trapped beneath warm air, a condition called a temperature inversion. This acts like a lid, bouncing sound downward, extending its reach. That's why a night storm can seem louder, longer, closer than a similar storm during the day. The sound is bouncing back toward you instead of rising up and dissipating. Moisture also changes things. Thunder sounds fuller, deeper, in humid air. The moisture helps carry the low frequencies, those rumbles that vibrate through your chest and roll across the ground like the footsteps of something immense. In dry air, thunder is crisper, sharper, less resonant. It arrives like a statement. In moist air, it arrives like a conversation. And the terrain matters too. Over water, thunder can carry for extraordinary distances. With no trees, no hills, no buildings to block or absorb it, the sound moves cleanly. Sailors and islanders have long spoken of hearing storms long before seeing them. The ocean acting as a mirror, reflecting both light and sound with eerie clarity. In the mountains, thunder becomes layered. It bounces and echoes, each crack folded into the next. A single lightning strike can sound like a barrage, repeating off cliffs and ridges until it seems the sky is shaking the entire landscape. In flatlands, thunder feels more linear, more focused, a direct line from sky to soil to ear. But sometimes, thunder isn't heard at all. It's felt. That deep, low-frequency energy moves through the ground. It rattles windows. It vibrates the soles of your feet. It stirs something in your chest that isn't quite fear but isn't peace either. A primal awareness. Animals respond instinctively. Dogs bark or cower. Horses stamp. Birds rise in swirling flocks. They feel the pressure long before we do. They don't need to measure. Their bodies understand. And in those moments when lightning flashes and you count 1, 2, 3, and the thunder finally comes, you are not just measuring distance, you are synchronizing with the storm. You are part of the equation. Your body is the receiver, the sky is transmitting, and the silence between the flash and the roar, that's the story unfolding. You learn over time how to read those moments. You learn that when the delay shortens, danger grows. When the thunder is constant, the storm is overhead. When the sky lights up and no thunder comes, the storm is far, or already moving away. Thunder isn't just a warning, it's orientation. You know where you stand, quite literally, by how the sky responds. Some people forget to listen. They watch the lightning, admire the beauty,
take photos, but they forget to count, to wait, to hear the response. But the thunder always follows, always. And when it does, it carries with it more than sound. It carries energy, it carries space, it carries the voice of the storm, reshaped by clouds, and hills, and trees, and the air itself. It's not just noise, it's context. It's the final note in a dialogue between earth and sky. So the next time the sky flashes, pause. Don't just look. Listen, because somewhere in the seconds between the light and the sound, the storm is telling you exactly where it is, exactly how big it's grown, exactly how close it plans to come. And when that thunder reaches you, it doesn't matter whether it came from 2 miles away or 20. For that instant, you and the storm are in the same place.
Chapter 10: The Electric Breath of the Earth. What thunderstorms give back. For all their fury, thunderstorms are not just destroyers, they are givers, restorers, silent architects of balance, reshaping the atmosphere every time they roll across the land. To most of us, a thunderstorm is noise and danger, a disruption. But beneath the flashing skies and trembling windows, something else is happening, something quietly essential. Thunderstorms feed the earth. Every time lightning strikes, it breaks the air apart at the molecular level. It rips nitrogen molecules out of their stable pairs, freeing them. These broken atoms quickly bond with oxygen, creating nitrogen oxides. Compounds that once dissolved in rain fall to the ground as natural fertilizer. This process, called nitrogen fixation, is critical to life. Without it, plants would not grow, ecosystems would struggle, and the food chain would falter. And so, from the violence of the sky, life is nourished. It's a strange trade. A flash of lethal energy in the upper atmosphere becomes nourishment in the roots of trees. We rarely think about this when watching a storm. But every field that turns green after rain, every forest that deepens in color, owes something to the chemistry of lightning. And that's just the beginning. Thunderstorms move heat. They redistribute energy from the surface to the upper atmosphere. When hot, moist air rises in a storm, it carries thermal energy upward, releasing it when water condenses into rain and hail. That energy powers wind currents, influences jet streams, and affects the balance between high and low pressure systems across entire regions. A single thunderstorm can impact weather patterns hundreds of kilometers away. They are, in essence, ventilation systems for the planet. Storms prevent the Earth from overheating in certain places and growing stagnant in others. They take what's built up, moisture, pressure, heat, and release it, often violently, but always with purpose. Without thunderstorms, the atmosphere would lose its rhythm. The build-up of energy would go unchecked. Balance would decay. Thunderstorms also cleanse. Rainfall generated by thunderstorms scrubs the air of pollutants, pollen, and dust. Each droplet collides with airborne particles, drawing them downward. After a strong storm, the air smells cleaner, feels lighter. That fresh, earthy scent, the one we sometimes call petrichor, is a mix of ozone and geosmin, the product of soil, rain, and atmospheric energy colliding in a kind of purification. Even thunder, the sound itself, plays a role. It's not just a byproduct of lightning. Thunder is acoustic energy, pressure waves traveling through the atmosphere. These waves move air, shake leaves, stir up particles. Some scientists believe thunder may even help disperse seeds, pollen, or airborne microbes in subtle ways, especially in forested regions. It's a living soundtrack that does more than inform. It acts. And there's something else. Something harder to quantify but deeply felt. Thunderstorms remind us of scale. They show us how small we are in the face of natural power, not to humiliate us, but to orient us, to restore perspective. When the sky flashes and the world shakes, It breaks through the illusion of human control. It resets something, not just in the atmosphere, in us. Think about how often you pause during a storm, how your senses become sharper, how you listen, count, wonder, how everything slows, how the digital world fades, and your awareness turns outward. That is a gift too. A storm doesn't just wash the land, it washes the moment, wakes something primal. For all our machines, satellites and sensors, we still experience thunderstorms the same way our ancestors did, with eyes wide, hearts alert, and a quiet respect for what we do not command. Thunder, in that sense, is not just noise. It's an ancient sound, older than language, that pulls us back to a more honest state of being. It tells us that the earth is still alive, and so does the sky. Even animals respond with reverence. Birds fall silent. Dogs seek shelter. Cattle huddle together. Elephants travel to lower ground long before the storm arrives. Creatures without radar, without forecasts, understand what's coming. They feel it. They listen. Perhaps that's what we're meant to do too. Not just explain the storm, but experience it. Not just shield ourselves, but tune in. Because these moments, as loud and inconvenient as they may seem, carry truths most of the world now tries to drown out. A thunderstorm is the earth talking to itself and letting us hear the conversation. When lightning rips across the sky, it's not just an electric discharge, it's a pulse, a realignment, and thunder is the sound of that correction echoing through the atmosphere. Sometimes storms arrive when the air is too heavy to hold itself together. Other times they seem to rise from nothing, from heat, from friction, from the way sunlight lingers too long in one place. But they always serve a function. They never arrive without cause. We may not always understand the timing, but the reasons are written in the pressure maps, in the rising air, in the imbalance between what is and what must be. And when the storm leaves, it doesn't just disappear. It leaves a cleaner atmosphere, a cooled earth, charged ground, and people sometimes shaken, sometimes reflective, always changed in some small way. Maybe we were meant to be, because what else could force us to pause in the middle of modern life? What else could draw our eyes upward, make us count seconds, feel the air before it moves, and recognize that something greater than ourselves just passed through? A thunderstorm gives us all of that, and then is gone. But the air it reshaped, the ground it touched, and the silence it leaves behind, stay, not as threats, as gifts.
Chapter 11. The Silent Approach. How animals sense thunder before we do. Before the first rumble rolls across the sky, before the flash even breaks the clouds, something stirs. A bird darts suddenly from a quiet tree. A dog shifts nervously, ears twitching. Horses cluster near the fence, restless without command. Somewhere in the tall grass, insects fall quiet. It hasn't rained. The wind hasn't risen. The storm to your eyes hasn't arrived. But to the animals it's already here, long before we hear the thunder. Long before we count the seconds between light and sound, the natural world begins to respond. It always. Animals detect what we often miss, not just with hearing or sight, but with skin, with fur, with instincts wired over thousands of years of watching the sky turn. To them, a thunderstorm is not a surprise. It's a signal. And it begins in silence. The pressure drops. Subtle but real. Barometric shifts affect air density, and while we rarely notice, animals do. Many species can sense minute changes in pressure, a storm's early footprint. It tells them the sky is about to change. It tells them where to go, what to do, when to stop foraging and start hiding. Then comes the shift in the air, not in temperature, but in charge. As the storm builds, the atmosphere begins to polarize.
Static electricity fills the sky. The air, once neutral, becomes electric. Animals are highly sensitive to this. Dogs often react to static discharge hours before a storm breaks. They pace, hide, bark at nothing. Some rub against walls, trying to ground themselves. Cats hiss at corners. Horses stamp, uneasy, as their coats stand on end. Even fish have been known to dive deeper in lakes as surface charges rise. It isn't myth, it's electroreception, a real and measurable sensitivity in many creatures, especially those with more contact to the ground or water. In fact, animals don't just feel the storm. Some can see it, not visually, but magnetically. Birds like pigeons and migratory species have magnetic sensors in their beaks or skulls. They use the Earth's field for navigation, but those same sensors react to sudden distortions caused by storms, especially ones involving lightning. Lightning releases a pulse, not just of light and heat, but of electromagnetic radiation. It ripples through the atmosphere. Some animals respond immediately, changing direction, ceasing flight, hunkering down. Bees may vanish from flowers. Frogs may grow silent. Bats may stay grounded. The electric breath of the storm tells them what's coming before we see a single cloud darken. Then there's infrasound, frequencies below the range of human hearing. Thunderstorms produce these deep pressure waves, especially when lightning rips through miles of air or when wind shear destabilizes the atmosphere. Elephants, whales, and other large mammals use infrasound to communicate over long distances. They can feel it in their bones, their feet, their skin. When a storm is still hours away, when the radar shows nothing but calm, these creatures already know. They've heard what we cannot. It's not just exotic animals. Domestic pets, dogs, cats, rabbits, all respond in their own way. Dogs may crawl under beds, whine, bark at windows. Cats may hide in closets or vanish into places they rarely go. Small mammals like hamsters or guinea pigs may freeze, silent and unmoving, long before the sky breaks. Horses are particularly sensitive, large, grounded, and perceptive. They often panic if not sheltered. Farmers and riders know a shift in herd behavior can mean a storm is on its way before any human system detects it. Birds are among the most visible responders. Entire flocks will change course. They'll drop altitude. Some will stop singing altogether. A chorus of morning birdsong falling silent is one of nature's earliest thunderstorm warnings. Some species are even known to abandon nests if a particularly violent storm is approaching. It's not cowardice, it's survival. Better to lose a clutch than to lose a generation. Even insects react. Ants, which rely heavily on pheromones and atmospheric cues, will often cover their tunnels before a storm. Bees return to hives. Butterflies vanish from meadows. Spiders retreat from webs. The collective motion of small lives responds with uncanny precision, as if they've read a script the sky hasn't shared with us yet. And it's not just land animals. Fish, too, feel the storm. The electrical changes in the air ripple into the water. Some species descend to deeper layers, where pressure and temperature are more stable. Others stop feeding. Reefs grow quieter. In aquariums, even in controlled conditions, fish may hide behind plants or inside rocks as the storm brews miles away. All of this before a single drop of rain falls. The natural world has always had its own warning systems, and they've always worked. Long before meteorology, long before barometers or satellite loop, there were the wolves who howled earlier, the horses who paced the barn, the birds that vanished from the trees. The way the dog wouldn't go outside, we ignored them at our peril. Some researchers are now trying to harness this biological early warning system in regions where weather infrastructure is lacking. Studying animal behavior could provide advanced warning of storms or even tornadoes. A flock
taking off all at once, a shift in herding patterns, a sudden migration from a nesting site. These movements may one day become signals as valid and trackable as radar echoes or wind charts. But the truth is, we don't fully understand it yet. We still can't say exactly how animals detect these changes, only that they do, and they've done it for thousands of years. Perhaps it's because they're closer to the earth physically and instinctively. They don't explain storms, they don't fear them in the abstract. They respond to what the body feels, a vibration, a change in charge, a quiet that means more than absence of sound. They don't need language to know what thunder means. And maybe we once understood that too. Maybe we once sat in caves or on riverbanks, feeling the pressure drop, watching the birds go silent, smelling the ozone in the air, and knowing without doubt, the sky is about to speak. We've built barriers, roofs, walls. We've sealed our senses behind glass. But sometimes when the storm comes, all of that vanishes. The dog is pacing. The air is thick. You feel a buzz against your skin. You pause, without knowing why. And then the first flash comes, and you realize the warning had already arrived. So the next time a storm brews and the animals begin to move, don't dismiss it. Watch the birds. Listen to the silence. Trust the pacing of your dog, the stillness of the cat, the way the woods grow quiet like something is holding its breath. They know what's coming, and they've been telling us long before thunder ever says a word.
Chapter 12: The Charge in the Air. Why thunderstorms feel personal. Sometimes a storm doesn't announce itself with a roar. It arrives with a feeling. You've experienced it, that quiet unease before a thunderstorm. The strange hush, the heaviness in the air, the way everything slows. It's not just imagination. It's not superstition. It's physics, biology, and something deeper, something hard to name but impossible to ignore. There's a reason we say the air feels charged, because it is. As a thunderstorm begins to build, the atmosphere becomes a field of opposing forces. Positive charges accumulate near the top of the cloud. Negative charges settle near the bottom. The ground responds in kind, aligning positive charges just beneath the surface, reaching up invisibly, like the earth is preparing to shake hands with the sky. This unseen dance creates electric fields that grow stronger and stronger as the storm develops. Long before lightning ever strikes, these fields are already pressing into everything, into soil, into trees, into you. That tingling sensation, that buzz on your skin, that sudden restlessness in your muscles, that's your body responding to the electric field. You are, after all, a conductor. Your skin, your hair, your nerves, they all react when the electric potential builds. Sometimes it's subtle, sometimes it's startling. People struck by lightning often report sensing something just before it happened. The prickling of their arms, the feeling of being watched, the taste of metal in their mouths. We don't talk about it often, but we feel it. Because thunderstorms don't just change the sky, they change you. Your ears pick up lower frequencies, your heart rate fluctuates, your breathing becomes shallow. It's not panic, it's attention. Your body enters a state of heightened awareness, the same state our ancestors would enter when they felt the rumble of hooves or the breath of a predator in tall grass. You may be standing in a kitchen, but your nervous system is standing in the wild. It knows something is near. Some people describe it as anticipation. Others say it feels like pressure on the chest, or a fog inside the head. For a few, it's dizziness. For others, it's a sharpening of focus, like the world becomes clearer right before it breaks. And it's not just physical. Storms stir memory, a smell, like wet pavement or hot earth, a sound, like wind rustling dry leaves, a flash through the window. These things bring us back to childhood summers, to moments of fear, to memories we didn't expect. Thunder doesn't just move through the sky, It moves through time. It reminds us of who we were the last time the sky lit up like this, what we felt, what we lost, what we survived. And in that sense, thunderstorms aren't just weather events, they are emotional events. You can feel completely alone when a storm passes overhead, or you can feel strangely connected to the trees, to the ground beneath your feet, to the billions of people across the planet who have stood under storms just like this one and felt the same air, the same charge, the same pull. In many ancient cultures, storms were not explained. They were felt. They were understood as visitations, moments when the heavens touched the earth. Lightning was divine, thunder was voice, and the wind that came before it was the breath of something greater. Whether you believed in gods or spirits or nothing at all, the experience was real, and it still is. Modern science can explain the charge, the voltage, the humidity levels, the wind shear. It can tell us how the clouds built themselves. It can calculate the angle of the strike and the volume of the thunder. But it still cannot fully explain the way it feels when the storm is on top of you. How your thoughts slow, how your senses sharpen, how you become for a moment part of it. There is a reason writers describe characters standing in storms during their most transformative moment. There is a reason so many of us step out onto porches, balconies, or open fields when the clouds darken, not to escape the storm, but to feel it, to be close to something that's alive in a way we can't control. There is clarity in chaos. There is silence inside the thunder. Sometimes we need that. When the pressure builds too high in our lives, when things no longer move, when emotion stagnates, a storm arrives, and we understand it instinctively, not with the brain but with the breath. We inhale the coming rain. We feel the static. We prepare for the crash. And when it comes, when the thunder finally breaks, when the lightning flashes too close for comfort, we don't run. We stand at the window, because there's something healing in the release. The sound shakes the house, the wind throws the trees, the rain rushes like a waterfall. But inside, something lets go. Tension you didn't know you were holding, thoughts you couldn't form. Storms move us, inside and out. And when it's over, when the air lightens, and the charge fades, and the thunder rolls off into the hills, you feel it, not just relief. Thunderstorms cleanse more than the sky. They leave behind a space that wasn't there before, a quiet that isn't empty. It's earned. The way you feel after crying, or laughing, or standing in awe of something too vast to name. That's why they feel personal, because they are. Because the same charge that moves through the clouds moves through you. Because the same air that shakes with thunder fills your lungs. Because the same storm that flashes miles above your roof also sparks something in your chest. Wild, ancient, and beautifully human. So when the next storm comes, don't just listen, feel it. Let it remind you how alive this world still is. How alive you still are. Chapter 13. When the sky touches fire. The hidden dangers of lightning on Earth. It begins with a flash, a thread of white fire cutting through the sky faster than your eyes can follow. And then, if you're close enough, a sharp, sudden crack, like the air itself being torn apart. The ground shakes. The lights flicker. You blink, and it's already over. But not really. Because when lightning touches Earth, it leaves more than just sound behind. Lightning strikes the planet over 8 million times every day, and while most of those bolts vanish into fields, forests, oceans, or empty plains, some leave scars, some start fires, some cause blackouts, injuries, death. We call them natural disasters. But the truth is, lightning doesn't need to be widespread to be devastating. One bolt is enough, and lightning doesn't ask permission. It doesn't aim. It finds the fastest path between imbalance and resolution. And if you're in that path, it doesn't hesitate. The most common type of strike is cloud to ground. These bolts appear to shoot downward. But in reality, they begin inside the storm. Negative charges at the base of the cloud reach for the positive surface below. An invisible leader descends, a narrow, branching filament of ionized air, searching for connection. Meanwhile, the earth responds. Invisible streamers rise from buildings, trees, people. When the two meet, the circuit completes, and the return stroke explodes upward with blinding speed and immense energy. That's the lightning we see. That's the boom we hear. But the danger isn't just in the light or sound. It's in the current. A single lightning bolt can carry upwards of 30,000 amperes, hundreds of thousands of times more than a household circuit. The temperature can reach 5 times hotter than the surface of the sun. It's so hot, so fast, that it can vaporize moisture in a tree instantly, causing it to explode. It can fracture rocks, melt metal, ignite a forest with one kiss of heat, and it doesn't need direct contact to do damage. Lightning radiates outward from its strike point. The ground current spreads across the surface, traveling through soil, water, and roots. If you're standing nearby, even dozens of meters away, that current can pass through your body. It can stop your heart. It can sear your nerves. It can leave behind those eerie tree-like scars known as Lichtenberg figures, beautiful patterns etched by pain. Then there's side flash, when lightning strikes something tall like a tree or pole, and jumps sideways to a person or nearby structure. And conduction, when lightning travels through wires, plumbing, fences, even moisture in the air, seeking out a better path. It doesn't always obey expectations, it follows physics. And physics does not flinch. Lightning can strike the same place twice, and often does. Tall structures like skyscrapers, broadcast towers, and mountain peaks are repeat targets. The Empire State Building is struck dozens of times a year. Airplanes, despite being made of metal, are designed to handle lightning, with electrical pathways that guide the strike safely across the surface and back out. Still, every strike is a risk. Every circuit, a decision made in microseconds. And sometimes, lightning strikes people. Some survive, some don't. It's estimated that hundreds of people are injured by lightning each year globally. The actual number may be higher, especially in rural areas without reporting. Survivors often describe the moment as a blinding flash, a feeling of being punched or lifted. Then darkness. Some lose memory. Some wake up on the ground, clothes scorched, shoes blown off, skin tattooed with branching scars. But the scars aren't just external. Some survivors live with chronic pain, neurological damage, PTSD. Some find metal in their pockets melted, zippers fused, phones fried. The lightning doesn't just pass through the body. It passes through identity, marking a before and after. There are myths about lightning, that rubber shoes protect you, that lying down makes you safer, that being indoors is a guarantee. But the truth is more complicated. Rubber soles don't matter. Lightning travels through the body before it considers your footwear. Lying flat increases contact with the ground, and with it, the chance of absorbing more ground current. And being indoors? It helps, yes, but only if you avoid contact with metal, plumbing, electronics. Taking a shower during a storm. Dangerous. Washing dishes. Risky. Using a wired phone. Don't. Because lightning doesn't need to find you directly. It only needs to find what you're touching. This is why modern buildings use lightning rods, conductive metal paths that safely guide strikes into the earth. It's not about prevention, it's about direction. You don't stop lightning, you invite it safely. But the earth is full of places without rods. Forests, fields, hillsides, desert. And it's here that lightning shows its other danger, fire. When lightning strikes dry grass or treetops, it can ignite wildfires. These fires may smolder for hours before flaring up,
especially in dry climates. In remote areas, a single bolt can spark infernos that take weeks to contain. Some of the largest wildfires in history have started with nothing more than a storm and a spark. And then there are explosions. Lightning has ignited fuel tanks, detonated gas lines, set off munitions. In 2016, lightning struck an oil storage facility in Mexico, triggering a series of catastrophic explosions. In 2021, a strike hit a refugee camp in Bangladesh, causing deadly fires. Wherever flammable material meets open air, lightning is a match. It can even strike volcanoes.
Yes, you read that right.
Volcanoes generate their own storms. Plumes of ash, rock and gas rising into the sky create friction, charge separation, and ultimately, volcanic lightning. These are some of the most violent and photogenic storms on Earth. A mountain erupting, framed by forks of white fire. It looks apocalyptic. It is. And yet, for all the danger, we still watch in wonder. We photograph lightning. We chase it. We count seconds between flash and boom. We stand at windows. We share videos. Because somewhere in us, there's awe. There's reverence. There's the recognition that this danger, this violence, is also part of the Earth's rhythm. The storm isn't wrong. It's just true. And truth can be both beautiful and brutal. So we study it. We build sensors. We deploy satellites. We use radio arrays to track lightning strikes globally, mapping each bolt in real time. These maps look like veins, like neural pathways, because that's what lightning is, a nervous system for the sky, a flashing, branching language that speaks in electricity and heat. And what does it say? It says, imbalance must be corrected. It says, the air can no longer hold what it's carrying. It says, energy will find a way out, and it will not ask permission. Lightning is the Earth's most powerful form of expression. Thunder is the sound of that expression being understood. So when you see it flash, remember what it's capable of. Not to fear it, but to respect it. To know that the sky you walk beneath is not still. It breathes, it builds, it remembers. And sometimes, when its charge becomes too great, it reaches down to touch the ground, not gently, but honestly. Because when the sky touches fire, it doesn't just burn. It reminds.
Chapter 14. The Architecture of a Storm. Why thunderstorms build the way they do. Look up during a storm, and you're not just seeing clouds, you're seeing structure, motion, design. A thunderstorm isn't just a loose gathering of moisture and heat. It's a system with shape, function, and a strange kind of symmetry. And the way it forms, grows, and breathes tells you more about its power than any forecast can, because storms are built, not born. It starts with lift, the rising of warm, moist air. That upward motion is the storm's foundation, like the first beam of a great cathedral. As the air climbs, it cools, condenses, and begins to form towering clouds. These clouds don't drift lazily, they rise like ambition, pressing upward, layer by layer toward the upper atmosphere. Each droplet, each frozen crystal, adds volume, adds weight, adds story. The more moisture that rises, the more energy that enters the system. Heat is released into the upper layers as water condenses, and that heat feeds the updraft. What begins as a quiet swell becomes a column of force, a conveyor belt carrying energy skyward. And then, something clicks. The cloud grows tall enough to reach a point where it can't rise anymore. The troposphere ends. The stratosphere begins. And the storm's vertical ambition hits a ceiling. But it doesn't stop. It flattens out. It anvils, spreading laterally, like the top of a mushroom cloud, or the palm of a giant hand pressed flat against the sky. That flat top is the storm's signature. a mark of maturity. From the ground it looks like a lid. From the air, it's vast and almost surgical in its smoothness, but below that lid, the storm churns. Currents still rise inside, still feed the machine. That's when the storm begins to organize. That's when its internal architecture takes shape. Inside the cloud, air moves in loops. Updrafts pulling moist air higher, downdrafts dragging cold air and precipitation back down. These currents form the storm's bone, and if the winds at different altitudes are moving at different speeds or directions, a condition called wind shear, the whole structure begins to tilt. That tilt changes everything. Instead of the updraft being choked off by falling rain, it stays clean and strong. It fuels the storm for longer. And when rotation begins, that tilt can evolve into a mesocyclone, a rotating updraft. Now the storm is no longer just rising and falling. It's spinning. That spin is what gives birth to supercells, the most powerful and persistent thunderstorms on Earth. Supercells are storms with identity. They last for hours. They move with purpose. They produce hail, high winds, relentless lightning, and sometimes tornadoes. From a distance they look like alien structures, massive, rotating, sculpted by invisible hands. You can see bands of clouds wrapping around the core. You can feel the wind shifting. You can hear the silence before the sound. And when they erupt, when lightning splits the sky in rapid, flickering strokes, it's not just the atmosphere releasing energy, it's the structure unloading tension. Each bolt, each roll of thunder, each downpour is the storm responding to its own design. Even in less dramatic storms, the architecture tells a story. Multi-cell storms consist of clusters of smaller thunderstorm cells. One dies, another is born. They feed each other, like runners in a relay. You'll see shifting lines of rain, pockets of lightning, bursts of wind that arrive in waves. These storms don't stay in one place. They travel, sometimes across states, sometimes across countries, growing, shrinking, reforming along the way. Then there are squall lines, long, narrow bands of thunderstorms that stretch across the horizon like walls of water and wind. These storms are flat, fast-moving, and often brutal in their simplicity. They rarely rotate, but they don't need to. Their strength comes from their collective momentum, from the way every part moves together. They drop curtains of rain, bend trees forward, and leave the air behind them wrung dry. And always, within every type, the thunder speaks. The shape of the storm determines the sound of the sky. In large, tall storms, thunder echoes from multiple altitudes, creating layered, rolling rumbles. In squall lines, it's a steady pounding, like distant artillery. In supercells, the thunder feels more spaced, more resonant, a symptom of the storm's towering depth and clear vertical channels. Even the way the clouds move tells you something. Watch a thunderhead rise, and you're watching air try to escape gravity. Watch the underside swirl and pulse, and you're watching boundaries clash between warm and cold, between ascending and descending, between moisture and pressure. Mammatus clouds, those pouch-like shapes that sometimes form beneath an anvil, are a sign of turbulence, of sinking air within a cooling upper layer. They look surreal, almost like the sky has turned inside out, but they're real. They're part of the structure. They are not warnings. They are details. They are evidence of the storm's complexity, because storms are not random. They are designed by laws, thermodynamics, fluid dynamics, electromagnetism. These laws build the towers of cloud, shape the flows of air, and decide when and where the sky will break open. Lighting travels along charged channels shaped by water and ice. Thunder rolls along paths sculpted by cloud shape, terrain, and wind. The storm is a sculpture. The storm is a machine. The storm is alive, and it grows with intention.
But nothing lasts forever. As the storm matures, it begins to decay. The downdrafts grow stronger, the cold air descends faster. Eventually the updraft can no longer rise. The engine falters. The anvil thins. The structure collapses from within. What was once organized becomes scattered. The system disassembles itself in silence, and soon all that's left is trailing rain, grey mist, and the memory of motion. But if you looked closely, if you watched the cloud build itself from the base up, layer by layer, current by current, you saw more than a weather event. You saw an architecture of power, a design that didn't come from a blueprint, but from balance, from heat, from tension, from the deep, patient rules of a planet trying to move energy from one place to another. That's what a thunderstorm is. Not chaos, structure, and thunder. Thunder is the sound of that structure being built, and sometimes the sound of it coming apart.
Chapter 15, Lighting Without Rain. The mystery of dry thunderstorms. Sometimes you hear it before you feel it, a low, distant rumble, then another. You look up, the sky is strange, not dark, not stormy, just hazy, pale, maybe even sunny. There's no rain. The wind is still, and yet the thunder keeps coming. It doesn't make sense at first. There's no downpour, no drops streaking across the pavement. No cool gust sweeping through the air like the breath of a storm. Just the sound, unmistakable, powerful, echoing through an otherwise dry and quiet world. This is the paradox of the dry thunderstorm. A storm with thunder, with lightning, but no rain to speak of. At least, not where you are. These storms are silent in the way they approach, but they carry fire. Their arrival feels like a contradiction. Their danger lies in invisibility, and the truth is, some of the most destructive forces from the sky don't come in rainstorms. They come in silence. Dry thunderstorms begin like all others, with heat, with lift, with rising moisture. Cumulonimbus clouds build upward, towering into the sky. Electricity gathers, ice particles collide and separate charges. The storm begins to charge up, preparing for lighting. But something is missing. Or rather, something vanishes before it reaches the ground. Rain. In dry thunderstorms, the rain does fall, but it evaporates before it reaches the earth. This process is called virga, rainfall that descends from the cloud base but evaporates in the dry air below. From a distance you might see streaks beneath a cloud, like wisps of white smoke or ghostly fingers trailing from the sky. But they vanish before touching soil. The atmosphere beneath the storm is simply too dry. The air, parched and hot, absorbs the moisture before it ever lands. And so while the sky explodes with light and thunder, the ground remains untouched. No water, no relief. But the lightning, that still arrives, and without rain to suppress the heat, without moisture to soften the blow, these bolts hit the ground hard and hot. They strike dry grass, brittle leaves, sun-baked soil. They ignite forests. They spark wildfires that grow before anyone even knows a storm passed overhead. In the western United States, in Australia, in arid regions of Europe and Asia, dry thunderstorms are among the leading causes of natural wildfire ignition. One spark, one bolt, 1 second, and acres of wilderness catch flame. The fires may not even start immediately. Sometimes the lightning heats the ground, smolders deep in the roots of a tree or in the mulch beneath a pine. Then hours later, when the wind picks up, when the temperature rises, the flame finally breathes. These are called holdover fires, and they're especially dangerous because they appear after the storm is gone. The sky's clear, the temperature climbs, and suddenly a plume of smoke rises from ground that seemed untouched. That's the legacy of a dry storm. It doesn't just pass through, it plants something.
Lightning without rain feels unnatural, but it's not rare. It happens more often than we realize, especially in areas where high pressure dominates, where long-term drought conditions meet bursts of instability in the upper atmosphere. These storms bloom in isolation, their tops towering and white, their bases high and rainless, their hearts full of electric tension, and they are especially cruel, because you hear the thunder, you want the rain. The sky promises something it doesn't deliver, and sometimes, instead of water, it delivers fire. This is why firefighters fear dry thunderstorms more than wet ones. Rain helps. Even a light drizzle can dampen kindling, slow a spread, offer resistance. But in a dry thunderstorm, the ignition comes without suppression. The fire starts alone in silence, often in remote places where it goes unnoticed, until it's already grown too large. And that's not the only danger. Dry storms can produce downbursts, sudden, violent columns of sinking air that slam into the ground and fan flames outward. These winds can scatter embers across ridgelines, across rivers, across fire breaks. A single bolt can cause a spark. A single downburst can turn that spark into a firestorm, all from a storm you barely saw coming. You may have felt the air shift. You may have seen a flicker in the sky, but there was no warning, no rainfall, no cooling wind, just a moment, just a sound, just the smell of something burning. Hours later, but for all their destructiveness, dry thunderstorms are not malevolent. They are symptoms of imbalance. They occur when the atmosphere is unstable above, but starved below, when the sky wants to give, but the earth is too dry to receive, when clouds build with purpose, but the space beneath them can't carry the weight of rain. They are a kind of misfire, a misconnection, and they remind us that water, for all its abundance in nature, is not guaranteed. That rain is a partnership. It must be allowed to fall. It must be caught, held, used. In regions suffering from long-term drought, dry thunderstorms are a bitter omen. They bring the drama of a monsoon, the noise of a sky in turmoil, but leave no healing in their wake. They rattle windows, they shake nerves, but the soil stays cracked, the crops stay thirsty, and the forests, they hold their breath. Sometimes you'll hear the thunder for hours, rolling from a distant range, like a warning drum. You wait for rain, you hope, but nothing comes. Just the echo, just the heat, and then somewhere something starts to burn. In satellite imagery, dry thunderstorms are easy to miss. The clouds look ordinary, no rain gauges trigger.
Chapter 16, Echoes in the Dark. Thunderstorms at night. There's something different about a thunderstorm after dark, not just in how it looks, but in how it feels. During the day, storms are spectacle. We see them form, grow, roll across the landscape like living towers. We track the shadows on the ground, watch the lightning slice the sky like cracks in glass. But at night, when the world is quieter, when vision gives way to sound, thunderstorms become something else. They become present. The first time you hear thunder in the dark, it feels like a whisper that forgot to be quiet. The flash comes first, sudden, bright, blinding through the window. It startles more than it illuminates. Then silence, and then the low, rolling sound, slower, long, as if the storm is taking its time, not just announcing itself, but inhabiting the sky. At night, your ears take over. You notice details you missed during the day. The texture of the thunder, the way it wraps around buildings, the way it fades into itself. You feel it in your pillow, in your chest, in the glass next to the bed. You track the timing of each flash and each boom like a heartbeat. You don't just hear it, you live with it, for as long as it stays. And there's a reason thunderstorms feel more intense after sunset. At night, the atmosphere changes. The ground cools faster than the air above, creating temperature inversions, layers that trap and bend sound. This allows thunder to travel farther, especially the deep, low frequencies that resonate through walls and floors. You might be lying in bed, listening to a storm happening miles away, carried to you by nothing more than a shift in how the air holds sound. The darkness amplifies the unknown. Every flash lights up a world you can't fully see. For a moment, you see your room lit like day, a tree outside frozen in silhouette, then darkness again. That flickering rhythm, light, black, light, becomes hypnotic, a strobe of tension and release. And when the thunder comes, you brace, because there's no way to predict the volume. Some rolls are soft, distant, like a reminder. Others crack so suddenly they make your heart lurch. That unpredictability keeps you awake, not out of fear, out of alertness. Thunderstorms at night plug directly into the nervous system. For some they're terrifying, for others comforting, but for everyone they are intimate. The world is asleep, the distractions are gone. The only thing left is you, and the storm, and the strange conversation that unfolds between them. In rural places, where there are no city lights, nighttime storms are even more dramatic. Every lightning bolt becomes a painting. The clouds invisible a moment ago are suddenly sculpted in white. You see the scale, you see the movement, then it's gone. A blank canvas, until the next stroke of electricity sketches it again, and the silence between flashes, it becomes alive. You find yourself counting 1, 3, watching the rhythm of the storm, tracking it, listening to the beat of something ancient playing out above your house. For animals, nighttime storms are unsettling. Birds stir from trees, dogs whine, horses shift in stalls. They can't sleep through it, because thunder is not just a sound, it's a presence. It fills space, it presses in. In the dark, where sight can't explain, instinct takes over. Children often wake up, they wander to doorways, looking for a parent, not always scared, just restless. Because even if they don't understand the storm, they feel the charge, they feel the vibration through the floorboards. Their dreams bend around the thunder, reshaping sleep into something closer to listening. And for adults, even if we pretend we're unfazed, we feel it too. There's a reason people write poetry about lightning at night, a reason painters try to capture that flickering silver, a reason musicians use thunder in ballads, in heartbreak, in mystery. Because something about the dark makes storms emotional. The lightning becomes memory. The thunder becomes reflection. Sometimes a storm is the only sound in the world. When the city sleeps, when the traffic fades, when the wind holds its breath, that thunder, miles away maybe, still reaches you, still wraps itself around your thought. Sometimes it feels like the storm is speaking not just to the land, but to you. And not all nighttime storms are distant. Sometimes they park overhead. Sometimes the rain drums so hard it becomes its own kind of thunder. Lightning flashes behind your eyelids, even with your eyes closed. The boom is instant. The air shakes, and you wonder how many people are awake at this very moment, hearing the exact same thing, feeling the same pulse, bound together by a storm. And when the storm leaves, it's just as strange. No fanfare, no final clap, just a slowing of the rain, a softening of the wind, a pause. The sky brightens slightly, with moonlight behind the clouds. The thunder fades to a murmur. You breathe differently. You realize you were holding something in, some piece of alertness, and now it's gone, replaced by stillness. But that stillness remembers. The room, now quiet, still holds the memory of the flashes. The walls, still echoing from the last roll. Your skin, still sensitive. Your mind, slower, softer, as if the storm left something behind that wasn't moisture, or wind, or even sound, but a kind of truth. That for a little while, you were reminded of your place under the sky, that you were small, yes, but not forgotten. Because nighttime storms don't demand an audience. They simply arrive. And if you're lucky enough to be awake,
They might just show you something you've been too busy to see, that even when the world is sleeping, the sky is wide awake.
Chapter 17. The sound of lightning. What thunder really tells us. If you listen carefully, thunder doesn't just make noise, it tells a story. Every crack, every rumble, every distant roll across the sky holds information. It's not random. It's not just the aftermath of a lightning bolt. It's a signature, a report, a broadcast from the atmosphere itself. Thunder is the Earth's way of saying, something just happened, and here's how big it was. But to understand thunder, you first have to go back to what caused it. When lightning rips through the sky, it doesn't just flash. It carves a channel through the air, a path of ionized gas called a plasma. This channel is only a few centimeters wide, but it's incredibly hot. Around 30,000 degrees Celsius, or 5 times hotter than the surface of the sun. That extreme temperature causes the air to expand violently, faster than the speed of sound. That sudden expansion creates a shock wave, a blast of compressed air that travels outward in all directions. What we hear as thunder is the echo of that shock wave, softened and stretched, as it travels through the atmosphere. But it's more than just a bang. Thunder varies not just in volume, but in texture, in length, in character. Some strikes crack like a whip, others roll like a drum. Some start sharp, then fade into deep growls that seem to shake the sky for seconds. Each variation has meaning. A sharp, loud crack usually means the lightning struck nearby. The shock wave had no time to scatter or lose strength. A low, rolling rumble means the strike was farther away. As thunder moves through the air, it reflects off clouds, hills, buildings, even the temperature layers of the atmosphere itself, bending and stretching into that long echo we know so well. And then there's timing. We've all done it, counting seconds between lightning and thunder. 1 Mississippi, 2 Mississippi. Every 5 seconds roughly equals 1 mile, or about. The delay between flash and boom is caused by the difference in speed. Light travels almost instantly to your eyes, while sound lags behind, crawling through the air at around 33 meters per second. But what if the thunder sounds fragmented? Sometimes it stutters, comes in bursts. That's because lightning rarely strikes in one clean line. It often branches, splitting into multiple paths as it searches for the quickest route to the ground. Each path generates its own shockwave, and when those waves reach you at slightly different times, you hear them as broken bursts, a kind of thunder mosaic. And what if you don't hear thunder at all? That can happen when a lightning bolt strikes too far away. The thunder can get refracted, bent away from you by layers of air at different temperatures, or it can get absorbed by the land, by buildings, by vegetation. There's even a term for lightning seen but not heard. Heat lightning. It's not different lightning, it's just too far for the thunder to reach you. But not all thunder is created equal. A single superbolt, bolt, a rare form of extremely powerful lightning, can produce thunder so loud it can be heard over 100 kilometers away, depending on terrain and condition. These are the strikes that break windows, set off car alarms, or feel like they exploded inside your own chest. Some places on Earth experience thunder so frequently and so predictably that entire cultures have built folklore around it. In Venezuela, there's a region where lightning flashes almost every night. The Catatumbo lightning, a persistent storm that produces thousands of strikes over Lake Maracaibo. The thunder that echoes through this area is relentless, sometimes lasting hours, bouncing off the water, the hills, and the thick, humid air. To the people who live there, thunder isn't just sound, it's a season. And then there are the mountains. High-altitude regions have their own thunder language. Sound moves differently in thinner air. It travels faster. It fades more quickly. You can hear it roll down valleys like liquid, or bounce between cliffs like a trapped voice,
looking for an exit. Sometimes thunder in the mountains feels closer than it is, and other times it disappears faster than you expect. Thunder is shaped by context, where you are, what the air is doing, how high the clouds are, how far the lightning traveled, how dry or humid the path was. All these variables sculpt the sound. They twist it, stretch it, hide it, reveal it. Even your house changes thunder. It vibrates in the windows, echoes in the walls. Thunder inside a city sounds different than thunder on an open plain. In cities, it bounces off buildings, car hoods, pavement. In fields, it rolls across grasses and vanishes into the horizon. In forests, it's muffled. In deserts, it's raw. And sometimes, the thunder surprises you. You see the flash. You wait, and when the boom comes, it's bigger than you expected, deeper, more violent. It feels like it came from inside your own bones. That's not just imagination. That's your body becoming a drum. Because low-frequency thunder, the kind you feel in your chest, travels better through solids than air. Your walls, your bed frame, your own rib cage become conduits. You don't just hear it. You are it. This is why thunder has such an effect on the nervous system. It's not just sound, it's pressure, it's vibration. It activates parts of the body that aren't used to listening. Skin, spine, gut. The boom of thunder bypasses the ears and plugs directly into awareness. It wakes you up, even when you're already awake. And for some people, thunder is more than sensation. It's emotion. It triggers memory, instinct, something from childhood, maybe, a summer night, a voice, a dog, hiding under a bed, a power outage, a candle, a moment when the world paused, not because you wanted it to, but because it had to, because thunder arrived. And thunder demands attention. There is no ignoring it, no muting it, no scrolling past it. Thunder is the ultimate notification, a reminder that something bigger than your life is moving outside your window, that the sky still has something to say. So next time the clouds flash and the sound follows, don't just count seconds. Listen. Hear the shape, the space between the booms, the length of the roll, the crackle inside the echo. Because that sound didn't just happen. It traveled. It chose a path. It found you. And in that moment, you're not just a bystander. You're part of the story. One breath beneath a sky full of electric conversation. One pair of ears among billions, tuned into the voice of a world still speaking in sound and light. That voice is thunder. And it always means something.
Chapter 18. The electrical heart of the storm. How lightning powers the skies. It begins with friction. Not the kind you feel when you rub your hands together, but a kind that lives between ice and air, between rising water droplets and descending hailstones, between chaos and balance. Deep inside the towering heart of a thunderstorm, countless particles collide, and with every collision, electrons are exchanged. Bit by bit, charge builds. Slowly at first, then exponentially. The top of the storm becomes positive, the bottom negative, and the imbalance grows until the sky can no longer contain it. And then, it strikes. Lightning is not random. It is the atmosphere's circuit breaker, a release valve for an overloaded system. It is how the planet discharges excess energy, how it resolves tension too great for the air to bear. And it is far more structured, far more intelligent than it seems. We think of lightning as a single bolt, a quick line of light that connects cloud and ground. But in truth, it's more like a process, a series of steps, invisible until the very last instant. It begins with what's called a stepped leader, a channel of ionized air that moves downward in jagged segments from the cloud, branching, pausing, seeking. As it nears the earth, it's met by streamers, electric tendrils that rise up from trees, buildings, even people. When one of these streamers connects with the descending leader, the circuit is completed. That's when the return stroke fires. And that's the flash we see. But even then, it's rarely just one stroke. Multiple discharges may travel the same path in rapid succession, making the lightning flicker. These strokes move at nearly 1/3 the speed of light. They illuminate the sky. They electrify the air. They carry current equivalent to thousands of car batteries discharging at once. And it's not just from cloud to ground. Lightning can also leap from cloud to cloud, from one charged region to another. These horizontal bolts can span tens of kilometers, lighting up entire sections of sky in one sudden burst. And sometimes, though rare, lightning travels from ground to cloud, fired upward like a silent scream from Earth itself. The most mysterious forms of lightning occur above the storm. They're called transient luminous events, sprites, jets, and elves. Brief, otherworldly flashes that burst into the upper atmosphere when a powerful lightning stroke disturbs the electromagnetic field above a thunderstorm. Sprites glow red like jellyfish. Blue jets shoot upward like spears of flame. Elves appear as expanding rings of light, flickering in the ionosphere. These phenomena were once dismissed as myth. Now we capture them on high-speed cameras. We study them from the International Space Station. We realize that lightning doesn't just strike below, it connects upward too. The storm is not a closed circuit. It reaches both directions, and what's perhaps most astonishing is just how common lightning is. At any given moment, there are around 2,000 thunderstorms happening around the world. Lightning strikes the Earth over 100 times per second. That's more than 8 million times per day. And yet we barely notice unless one happens nearby. But the sky notices, because lightning isn't just spectacle, it's function. Each strike helps to balance the global electrical circuit. The Earth has a natural electric field, with the surface generally negatively charged and the upper atmosphere positive. Thunderstorms act as batteries, transferring charge and helping maintain this planetary voltage. In essence, the planet is constantly recharging itself, and lightning is the wire. And yes, lightning can even affect life, not just in terms of danger or damage, but biologically. There is a theory that prebiotic chemistry, the first stirrings of life on Earth, may have been jump-started by lightning. In the famous Miller-Urey experiment, scientists simulated early Earth's atmosphere and introduced electrical sparks. The result: organic molecules, the building blocks of amino acids. Lightning may have helped create the very molecules that became us. Even now, lightning has a strange relationship with biology. It can trigger chemical reactions in soil, breaking down nitrogen into forms that plants can absorb. It alters the electrical field of the atmosphere, which some animals like birds and insects may be able to detect and navigate by. Some creatures react to lightning before we ever see a flash, sensing the change in air pressure or electromagnetic charge. The storm speaks, and life listens. But lightning also reminds us how fragile our systems are. A single bolt can knock out power grids. It can fry computers. It can overload transformers, spark blackouts, and ripple across cities. It's not just about physical damage. It's about electromagnetic interference. Lightning doesn't only bring light and heat. It brings noise in frequencies that disrupt signals, scramble data, silent satellites. In a world that runs on electricity, lightning is both ancestor and threat. It gave us our first understanding of natural power. It now challenges our modern dependence on it. And yet, for all its violence, lightning is still among the most beautiful things we witness. It strikes with geometry. It branches like trees, like rivers, it's fractal, a visible reminder that the patterns written into our bodies are the same ones that govern storms, that chaos and order are not opposites, but partners. In a single flash, lightning compresses force, heat, light, time and balance into one expression. And thunder, that's just the echo.
just the afterthought of something enormous, something necessary, something the earth had to release. We build towers to guide lightning away. We design aircraft to survive its kiss. We teach children to count seconds between the flash and the roar. But deep down we still look up in awe, because lightning is not just weather. It's the heart of the storm. And sometimes when the clouds are full and the sky can no longer hold its silence, that heart beats so loud, the whole world hears it.
Chapter 19. When lightning strikes twice, myths, patterns, and the truth about risk. There's a saying people toss around when the unlikely happens: lightning never strikes the same place twice. But that's not true. Not even close. Lightning can, and often does, strike the same place more than once. In fact, some places get hit hundreds of times a year. Skyscrapers, mountain peaks, broadcast towers, trees that rise above the canopy, anything that makes itself a target, by height or conductivity or placement, is fair game. Because lightning doesn't remember, it doesn't get bored, it doesn't play by human ideas of fairness. It simply follows physics. Electricity takes the path of least resistance. If that path was good once, it will likely be good again. That's why the Empire State Building is struck nearly 25 times each year. Why airplanes, despite being airborne and moving, get struck regularly. Why certain trees in open fields become scars of blackened bark over and over. The real question isn't if lightning can strike twice, but why we believed it wouldn't. Maybe because the idea offers comfort, a way to frame danger as rare, to turn fear into fable. We want to believe that misfortune, once it finds us, will pass over next time, that it's done. But nature doesn't work that way. It works in patterns. And lightning, though seemingly chaotic, has preferences. It prefers tall, isolated objects. It seeks out conductivity, metal, moisture, anything that offers a highway for charge. It likes sharp points, the tips of flagpoles, antennas, spires. It's drawn to density differences in the air, to regions of iron buildup, to invisible structures built by storm and terrain. But it's not just about the object, it's about the storm itself. Some lightning strokes branch outward, hitting several points in succession. Some follow established channels from previous strikes, reusing the same path, like a well-worn trail. Some bolts are positive lightning, rarer, more powerful discharges that originate from the tops of thunderclouds and travel farther across the sky before touching down. These are the ones that catch people off guard, striking miles from the storm. They don't follow the center of the chaos. They reach into the quiet, and that's where the danger lies. You can be standing beneath blue sky, far from rain, and still be at risk. A phenomenon known as a bolt from the blue. These strikes are especially dangerous because they're unexpected. They often hit ahead of the storm, coming out of what looks like calm. People assume the threat has passed, or hasn't arrived yet, and they're wrong. The storm doesn't have to be above you. It just has to see, which leads to another myth, that certain people attract lightning more than others. Statistically, it's not personal, it's situational. But some people do get struck more than once. The most famous case, Roy Sullivan, a U.S. park ranger, who was struck by lightning 7 times between 1942 and 1977. He survived every strike. Each incident was verified. Roy became known as the human lightning rod. Some called him cursed. Others called him lucky. But the truth is simpler. He spent much of his life outdoors, in mountainous terrain, during storms. He was exposed repeatedly, in places lightning already wanted to be. So no, it wasn't magic. It was proximity. And yet, Lightning strikes still carry a kind of mythic weight. There's something intimate about them, personal, violent and direct. Unlike a flood, or a windstorm, or a fire, lightning chooses its target, or so it seems. It comes from nowhere. It leaves behind scars on earth, on objects, on people. Survivors often describe strange after effects. The smell of burning hair, the taste of metal, the vision of a blue-white flash burned into memory. Some develop long-term neurological symptoms. Others are left with Lichtenberg figures, tree-like scars, that map the path electricity took through their skin. These marks fade with time, but they are reminders that for a brief moment, the body became a conductor, that the storm didn't just pass by, it passed through. We like to think we're grounded, but during a storm, we are part of the circuit, and this brings us back to risk. Most lightning fatalities don't happen to people doing dangerous things. They happen to people doing ordinary things. Hiking, swimming, golfing, mowing the lawn, being outside at the wrong time, standing under a tree, taking shelter beneath a metal roof, or next to a fence, sometimes even just talking on a landline, or leaning against a concrete wall reinforced with steel. Because lightning is opportunistic. It doesn't target, it responds. To height, to moisture, to metal, to your position in an electric field you can't see or feel, until it's too late. And yet, the risk is still rare. Your odds of being struck by lightning in your lifetime, about 1 in 15,000, depending on your location, habits and exposure. Most people will never come close. But for those who live in lightning-rich regions, Florida, the Congo Basin, the Himalayas, the odds go up. For those who spend more time under open sky, the odds rise again, and the danger isn't always direct. Lightning can jump, known as side flash, from a struck object to a person nearby. It can travel through plumbing, wiring, or even wet ground. It can affect multiple people at once, especially if they're grouped closely. It doesn't need to hit you directly to harm you, which is why the best defense is always awareness. If you hear thunder, you're already in range. If you see a flash, don't wait for rain. Seek shelter in a car, a building, not a tent, not under a tree, not beside a rock face. Wait 30 minutes after the last thunder before returning outside. These aren't overcautious rules. They are the product of pattern recognition, forged in the experience of thousands who didn't make it home. And what about those places where lightning seems to return? Again and again. They exist. Lake Maracaibo in Venezuela, the Kifuka region of the Congo, the Himalayan foothills, certain ridgelines in Colorado, broadcast towers in Chicago. There are zones where the storm loves to linger, where the air, the topography and the climate all conspire to invite lightning back. And in those places the phrase "lightning never strikes twice" doesn't just sound wrong, it sounds dangerous. Because ignoring patterns doesn't make you safer, it makes you blind. Lightning is not a trickster god. It's not a punishment. It's not a metaphor. Until we make it one. It is energy doing what energy does, moving from one imbalance to the next, finding paths, leaving marks, reminding us in one sudden flash how exposed we truly are, and how connected everything really is. So no, lightning doesn't forget. It doesn't forgive. It doesn't follow rules written in Proverbs. It strikes, and sometimes it comes back, not to punish, not to prove a point, but because the sky never stops looking for release, and the earth never stops offering paths. Chapter 20. Thunder and the Shape of the Land. How terrain sculpts sound. Thunder is not just shaped by the sky, it's shaped by the ground beneath it. The roar we hear after lightning isn't just traveling through open air, it's bouncing, reflecting, bending, shaped by mountains, valleys, forests, fields, and cities. Every surface it touches becomes part of its journey. Every echo tells us something not just about the storm, but about the landscape itself. In wide, flat plains, thunder stretches long and low. It rolls like a drum, uninterrupted, echoing across great distances. It feels endless, not because the storm is larger, but because there is nothing to stop the sound. The air is free to carry it as far as your ears can reach. You hear every contour of the strike, every layer of rumble peeling away into silence. But climb into the mountains, and thunder changes. Here the terrain breaks sound into pieces. Cliffs reflect it, peaks scatter it, valleys trap it, and throw it back. One lightning strike can sound like many, a burst of overlapping booms, each slightly delayed. You might hear it bounce from ridge to ridge like a voice looking for a way out. It feels close, even when it's not. And sometimes the sky flashes white, while the sound seems to come from behind you. A trick played by the land. In forests, thunder is muffled. Trees absorb the sound. The canopy acts like a giant sponge, soaking up the sharper edges. What you hear is softened, still powerful, but more distant, as though the storm is wrapped in cloth. And underneath the trees the ground vibrates instead. You feel it in your boots, in the bark, in the bones of fallen logs. The same bolt in the desert behaves differently, with little moisture in the air and nothing to dampen or reflect sound. Thunder in arid places can arrive dry and sharp. It cracks, it pops, then it vanishes fast. The silence after is thick, like the land swallowed the sound in one bite. The air is too empty to carry echoes, the ground too hard to reflect them. In cities, thunder becomes chaos. It collides with buildings. It gets trapped between alleyways. It reflects off windows, car hoods, skyscraper glass. The same strike might reach you from multiple directions at once, creating a surround sound effect. Disorienting, dramatic, sometimes beautiful. It pulses through concrete. It shakes steel. If you're inside, you might hear it hum in the plumbing or buzz in your appliances. The storm speaks to the entire infrastructure. And in caves, if you're ever unlucky or brave enough to be inside one during a storm, thunder turns into something else entirely. It doesn't just echo. It resonates. The sound doesn't stop where the walls begin. It enters the stone, vibrates the minerals, becomes a low, impossible to ignore hum that you feel in your chest before you hear it in your ears. It's not the thunder itself, it's the memory of it, caught and reshaped by rock. Bodies of water add their own flavor. Over lakes, thunder skates. Over oceans, it rolls forever. Water is a sound mirror. It reflects noise in smooth waves, carrying it farther and more clearly. A distant storm over a bay might sound closer than it really is. A lightning strike over calm water will split the night into two, sky and reflection, as thunder ripples across both. And then of course there's snow. A winter thunderstorm, rare, strange, creates thunder that feels muted, like it's breathing through a blanket. The snow absorbs some of the sound before it travels far. The storm feels smaller, closer, more personal. Thunder in snow is a whisper with weight, heavy, soft, unsettling. You hear it, but also you don't. All of this means thunder doesn't just describe the storm, it describes the world around it. You could, in theory, learn about the land just by listening. A long, clean roll might tell you the terrain is open. A sharp, echoing crack might hint at cliffs. A confused, bouncing boom might mean buildings. With the right ears, thunder becomes cartography. And it doesn't stop at the land. Thunder interacts with the air, and the air too is shaped by where we are. Humidity changes sound. Warm, moist air carries thunder better, letting it travel farther.
Dry air dampens it. Wind bends it, carrying sound towards some places, away from others. Even temperature layers, known as inversions, can trap thunder close to the ground, or lift it high above, changing how we perceive distance and direction. This is why some storms feel louder than they should, and why others sneak up silently until they're directly overhead. At night, these effects intensify. The land cools faster than the air above. This causes more sound reflection, more bending, more echoes. You hear more thunder at night, not necessarily because the storm is stronger, but because the land is helping the sound reach you. The earth participates in every boom, and when we build on it, towers, roads, bridges, we reshape thunder once again. There are places where one lightning strike might set off car alarms blocks away, not because it was unusually strong, but because the sound bounced just right. There are neighborhoods where thunder always sounds farther than it is, because of sound shadows cast by nearby hills or buildings. There are stadiums where thunder hits like a roar because of their design. Rounded, open, reflective. Even underground spaces feel the storm differently. Subways, basements, tunnels. They may not hear the thunder directly, but they feel the pressure, the pulse, the low-frequency hum that sneaks into infrastructure and makes the walls gently tremble. If you're deep enough, thunder is not a sound anymore. It's a sensation. All of this reveals something quietly profound. Thunder is not just a product of the storm. It's a conversation between lightning, air, and land, between sky and surface, between the invisible and the physical. It is shaped by ridges and rivers, by leaves and lakes, by rooftops and sand. Every crack you hear is an interaction, every echo a journey. And when you pause to listen, really listen, you're not just hearing the weather, you're hearing the story of the place you're standing on. So the next time the sky lights up and thunder follows, close your eye, ignore the flash, forget the forecast, just listen. Ask yourself, what is the sound telling you? Not about the sky, but about the ground.
Chapter 21. Thunder and the Brain. Why storms affect how we feel. There are sounds that we process, and then there are sounds that possess us. Thunder doesn't just echo through the sky, it echoes through the body, through memory, through emotion. It's not just something we hear, it's something we feel, something we remember, something that sometimes won't let us sleep. But why? Why does thunder, more than rain, more than wind, reach so deep into the nervous system? The answer begins with our most primal programming. From the earliest days of life on Earth, storms have meant danger. They brought fire from the sky, flash floods, falling trees, sudden death. Long before language, before culture, before roofs and forecasts, we learned to fear the boom. That instinct, carved into our DNA, never left. It's part of what kept us alive. So even now, in safety, surrounded by walls, thunder still activates something ancient. Not a conscious fear, but a biological alert. It triggers the amygdala, the brain's alarm center. Your heartbeat quickens, your muscles tense, your attention sharpens. Even if you know you're not in danger, your body acts like you are. That's the power of low-frequency sound. It bypasses rationality. It taps into something deeper. And not all thunder feels the same. Some strikes startle, sharp, loud, close. These provoke a fight-or-flight response, a burst of adrenaline. Others rumble in the distance, rolling slowly like drums under the earth. These don't scare, they haunt. They stir a different kind of emotion. Wonder, melancholy, awe. That's because thunder doesn't just engage the amygdala. It lights up the limbic system, the part of the brain that controls emotion, memory, and mood. When a storm passes overhead, we're not just reacting to the noise, we're reacting to everything the noise reminds us of. A childhood summer, a power outage, a face by candlelight, a pet trembling under the bed. a time when the world felt fragile and quiet and close. The sound of thunder opens the floodgates of nostalgia. It pulls up moments we didn't know we'd kept. Some people feel peace, others feel dread. Some weep without understanding why. Storms don't just shake the sky, they shake us. There's a term for this emotional weather sensitivity: meteoropathy. People with meteoropathy experience physical or psychological symptoms triggered by changes in weather: headaches, fatigue, anxiety, even depression. And thunder, with its pressure changes and acoustic violence, is often a catalyst. But it's not all negative. For many, thunderstorms bring comfort, not despite the noise, but because of the sound of thunder can create a safe container, a wall of noise that isolates you from the rest of the world. Inside that wall, you're still, you're reflective, you're allowed to be slow. This is why so many people use recordings of storms to sleep, to meditate, to think. The rhythm of rain, the pulse of thunder, the gentle growl of a distant sky. It creates a mental shelter, a space to process emotions you've been too busy to feel. And there's science behind that. Studies have shown that white noise, especially low-frequency noise like thunder, can help calm the brain. It masks sudden external sounds that might startle you awake. It promotes deeper, more consistent sleep cycles. It soothes hyperactive neural pathways. In fact, there's a reason therapists often recommend storm sounds to people with anxiety. The storm outside mirrors the storm inside, but offers a resolution. The thunder comes, the rain falls, and then eventually it fades. A promise. No storm lasts forever. But for others, thunder is a trigger. For veterans, for trauma survivors, for those whose nervous systems associate loud booms with danger, fireworks, gunshots, explosions. For them, a lightning strike isn't poetic, it's painful. It brings back moments they'd rather forget. Their heart doesn't race out of awe, it races out of fear. And this too is real, because thunder, like any powerful sensory experience, connects to whatever meaning we've given it, consciously or not. It becomes a vessel, a symbol, a metaphor. It carries more than sound. It carries history. And still, for others, thunder isn't a problem. It's a signal. There are those who feel energized during storms, creative, awake, alive. Something about the air, the electricity, the smell, the sound, sparks the mind. Artists paint, writers write, musicians compose. The storm outside becomes a mirror for the storm inside, and suddenly they have language. That's not superstition, it's neuroelectricity. The brain is an electrical organ. It reacts to electromagnetic fields, and lightning, especially nearby lightning, changes those fields. Some studies suggest that bursts of atmospheric electricity can subtly alter brainwave patterns, shifting mood, attention, even intuition. It doesn't affect everyone the same way, but for those who are sensitive, it's like their thoughts wake up with the storm. They become part of it. And beyond all that, thunder also does something quietly powerful. It interrupts a busy mind, a spiraling thought, a moment of distraction. Thunder breaks through. It reorients attention. It reminds you, forcibly and instantly, that something bigger is happening outside of you. It puts things in perspective. You stop typing. You stop scrolling. You just listen. And in that pause, something opens. A space, a breath, a moment to be fully present, not in your plans or your problems, but in the now, in the body, in the pulse of the world around you. And this is perhaps the most profound gift of thunder. It is now. It cannot be saved. It cannot be repeated. It cannot be ignored. You don't schedule thunder. You witness it. And sometimes, that's exactly what the mind needs. A reminder to stop,
to feel, to exist. So the next time the sky begins to tremble, ask yourself not what you hear, but what you feel. Is it fear? Is it memory? Is it calm? Is it awe? Whatever it is, let it speak, because the thunder is not just outside, it's also within.
Chapter 22. Charged Skies. How thunderstorms breathe electricity into our world. Step outside during the moments before a storm, and something shifts. The wind changes direction. The temperature drops slightly. The air grows heavy not just with moisture, but with something harder to define, a tingling on the skin. A strange quiet, a sense that the atmosphere is holding its breath. This is the charged pause before release. A moment where the sky is gathering energy faster than it can let it go. Every thunderstorm is an engine of electricity. It's not just rain clouds and wind. It's a living circuit, a machine that breathes in moisture and heat and breathes out lightning and sound. It transforms ordinary air into a medium for charge. The storm becomes a battery, building voltage across its layers and across the sky itself. But how does the sky get charged at all? It starts with rising warm air, called updrafts. These currents carry water vapor high into the atmosphere. As the vapor cools, it condenses into droplets. Some droplets freeze into ice crystals, some grow larger, turning into hailstones, and inside the cloud, everything begins to collide. These collisions between droplets, crystals, hail, generate friction, which builds up static electricity, like rubbing a balloon on your hair, but on a massive, violent scale. The lighter, positively charged particles rise to the top of the cloud. The heavier, negatively charged ones sink to the bottom. The result is a huge electrical gradient, a split personality sky. But the storm isn't just building charge, it's reaching for balance. And below the cloud, the earth responds. The buildup of negative charge at the base of the storm induces a positive charge on the ground below. Trees, buildings, even people. Anything under the cloud becomes part of the electrical map. The air between cloud and ground acts like an insulator until it can't anymore. When the tension reaches a tipping point, the storm discharges violently, suddenly, in the form of lightning. But even before the bolt, the electrical field is already affecting everything it touches. You might feel it as a prickling on your arms, or see it in the way your hair stands on end. Sometimes the field is strong enough to make metal objects hum. In rare cases, people even report a blue glow at sharp tips, a phenomenon known as St. Elmo's fire. It's not fire, it's plasma, ionized air, caused by strong electrical fields, and it's a sign that the atmosphere is nearing its electrical breaking point. But what's truly fascinating is how this charged environment doesn't just set the stage for lightning. It also interacts with everything else. For instance, it affects radio waves. Thunderstorms generate bursts of electromagnetic interference called spherics. Sharp, crackling noises heard on AM radios. If you tune to an empty frequency during a storm, you'll hear it, the popping and hissing of electricity dancing in the distance. These aren't just static, they're signals, natural broadcasts from the storm itself. And if you go higher, into the realm of very low frequency VLF waves, you'll find that lightning strikes can travel for thousands of kilometers, bouncing between the Earth's surface and the ionosphere. Some of these signals even circle the globe multiple times. In this way, a single strike in one part of the world can be heard around the planet, not by ears, but by machines listening to the electromagnetic heartbeat of the storm. But the storm's reach doesn't end there. It affects biology too. Electric fields during a storm can influence the behavior of animals. Birds fly lower, bees return to the hive. Cows lie down. Some fish become more active. Migrating species that rely on Earth's magnetic field may get confused. Even plants may respond, Some studies suggest that high voltage fields can affect the opening and closing of pores on leaves. And then there's the human body. We are in many ways electrical beings. Our hearts beat through rhythmic electrical impulses. Our brains fire signals across neurons. Our cells maintain voltage differences across membranes. So when the air becomes charged, we don't just observe the change, we participate in it. Some people are more sensitive than others. They feel storms before they arrive. They describe headaches, joint pain, strange moods. For them, the sky is not just weather, it's a pressure system that presses inward. And while science is still exploring these claims, one thing is clear: we are not separate from the storm. We are wired into it, and perhaps most astonishing of all, lightning, for all its violence, does good. It breaks apart nitrogen molecules in the air, allowing them to combine with oxygen to form compounds that nourish plants. In this way, lightning fertilizes the earth. Without it, life would struggle. The very storms we fear are also the storms that feed us. They do damage, yes, but they also sustain. And that contradiction, beauty and danger, destruction and nourishment, is what makes thunderstorms so endlessly fascinating. They're not just background noise, they're not just weather, they're a system, complex, dynamic, alive. And every time thunder rolls, it's telling us that the system is working, that imbalance has been detected and resolved, that energy is moving, that the sky is not static, but breathing, that we live inside a web of electricity, even when we can't see it. And when we do see it, when the sky splits open and fire dances across the clouds, we're not just witnessing weather, we're witnessing the Earth's own pulse. A reminder that power doesn't just live in our devices, it lives above us, around us, and sometimes it speaks. Chapter 23, The Language of the Storm. Can thunder be measured, predicted, or understood? We often think of thunder as wild, unpredictable, a chaotic aftermath of lightning's fury. But what if we told you thunder speaks a language, not one with words, but with frequency, amplitude, timing, and information? Because thunder, when listened to closely, doesn't just rumble. It reveals, it tells us where lightning struck, how powerful it was, how far it traveled, and even, sometimes, what kind of path it carved through the air. In fact, thunder is more than a sound. It's a signature, a trace left behind, and modern science is learning to read it. Let's begin with something familiar. You see lightning. You count. 1, 2, 3. Then comes the boom. Every second between flash and thunder equals about 1/3 of a kilometer, or roughly 1/5 of a mile. This isn't just folklore, it's physics. Light travels much faster than sound, so you always see lightning before you hear it. The gap between them gives you the distance to the strike, but that's just the beginning. Listen more closely, and thunder changes its tune. A nearby strike might come as a single sharp crack, like a gunshot. That means the bolt was close and direct, often vertical, and the sound reached you before it had time to scatter. A distant strike, however, rolls slowly. A low, drawn-out rumble. This is because high-frequency sounds, the sharp tones, dissipate more quickly in air. Only the lower tones travel long distances. By the time thunder from a distant bolt reaches you, it's been filtered by the atmosphere, softened, stretched. In this way, the sound of thunder contains distance, direction, and texture. But with the right instruments, we can extract much more. Using arrays of microphones, scientists can triangulate the origin of thunder in three-dimensional space. By analyzing the time delays between when each mic picks up the sound, they can reconstruct the exact path of the lightning bolt. Not just where it hit, but how it moved through the sky. Did it fork? Did it branch? Did it pulse multiple times through the same channel? Thunder holds those answers like fingerprints in the air. Even more fascinating is the use of infrasound, sound waves below the range of human hearing. Some thunder produces infrasound that can be detected hundreds of kilometers away. These low-frequency waves travel vast distances without losing strength, especially at night when the air is cooler and dense. Infrasound sensors placed around the world can pick up these signals and feed them into global lightning detection networks. That's right, we have a planetary system listening to storms, not just with eyes, but with ears. Satellites orbiting Earth detect lightning flashes from space. Ground stations measure electromagnetic pulses, and now acoustic systems listen to thunder, cross-referencing data in real time. Together they form a map, one that tracks every major thunderstorm on Earth, moment by moment. This map isn't just for curiosity, it's for safety. By studying thunder and lightning together, meteorologists can identify severe weather patterns faster. They can warn pilots to avoid specific air corridors. They can give communities early alerts for potential hailstorms or tornadoes. Because where thunder lives, danger may follow. But some scientists are going even further. They believe thunder may one day reveal the inner structure of a storm. By analyzing subtle differences in pitch, delay, and echo, researchers are building models that could show how thunder reflects off different layers inside the cloud. It's like echolocation, but for weather. Think of it this way: bats use sound to see in the dark. Whales use sonar to navigate the deep. What if we could use thunder to see inside a storm? This idea isn't science fiction. It's the beginning of storm acoustics, a field where sound becomes sensor, where we no longer rely only on radar or satellite. We listen, and from those rumbles we reconstruct shape, size, and strength. It's a field still in its infancy, but the potential is massive. Because sound interacts with air differently than light or radio waves, it can be scattered by humidity, reflected by turbulence, delayed by updrafts, and every one of these interactions adds a data point to the thunder we hear, which raises a thrilling possibility. Could we one day predict the intensity of lightning before it strikes, simply by understanding how thunder behaves as a system charges? Imagine that, not just listening to the sky react, but listening to the sky prepare. But beyond the science, there's something poetic about this idea, that thunder, this sound so often dismissed as noise, is actually organized, that within the chaos is pattern, that if we listen closely, we can hear the sky thinking. And perhaps it goes deeper than just meteorology. Maybe thunder is not just a tool for prediction. Maybe it's a way of remembering where we are and what surrounds us. Because thunder does what few natural sounds can. It demands attention. It breaks through conversation, technology, distraction. It reconnects us to the moment, to the sheer scale of the environment we inhabit. And maybe, just maybe, that's its true purpose. Not to frighten, not to warn, but to remind that we are small, that we are connected, that above us, something ancient is always moving, always measuring, always murmuring in frequencies most of us will never hear. So the next time thunder speaks, ask yourself, what is it saying? What is it echoing through the folds of the sky? What secret of the storm does it want you to hear? If only you'd learn to listen. Chapter 24. When thunder speaks from space, storms beyond Earth. We tend to think of thunder as an earthly sound, grounded, familiar, local. But what if thunder, or something like it, echoes far beyond the clouds of our own planet? What if lightning rips through alien skies, and the silence of space isn't so silent after all? As we extend our reach into the solar system, we've begun to realize something startling. Earth is not the only world that crackles with electrical storms, and where there is lightning, there may also be thunder, or at least its alien equivalent. Let's begin close to home. Jupiter. The largest planet in our solar system is a storm machine beyond comprehension. The Great Red Spot, a massive cyclone that has raged for centuries, is just the tip of its atmospheric iceberg. High above Jupiter's banded clouds, spacecraft have detected powerful bursts of radio waves, signals that match the electromagnetic signature of lightning. In fact, Jupiter's lightning is up to 10 times more powerful than Earth's, and it happens constantly. The Galileo spacecraft, and more recently NASA's Juno mission, recorded these electrical events in astonishing detail. Not only does Jupiter produce lightning, it produces a form of it that emits strong dichometric radio bursts. Bursts so loud that if you converted them to audible sound, they would create a kind of eerie electric thunder unlike anything heard on Earth. But would you hear it with your ears? That's the mystery. Jupiter's atmosphere is made mostly of hydrogen and helium. Its air is dense, but different. Sound can travel there, in theory, but what it would sound like is hard to say. Still, if you stood in a floating pressure-stable pod within Jupiter's upper clouds, you might feel the vibrations. You might hear the echoes of a superstorm. You might even flinch at the flicker of a giant bolt followed by a deep alien rumble. And Jupiter is not alone. Saturn too has lightning. And not just rare flickers, we're talking planet-wide storm systems. During a storm in 2009, Saturn's atmosphere exploded with so much lightning activity that it became one of the most powerful weather events ever recorded in the solar system. Saturn's lightning also produces radio emissions, picked up by the Cassini spacecraft and known as Saturn electrostatic discharges, SEDs. Imagine thunder rumbling through a golden haze of ammonia and hydrogen, lightning painting rings in shadow, a storm with no sky, just depth and gravity. What about other planets? Venus was long thought to be electrically silent, but recent missions suggest otherwise. Its atmosphere is thick, 90 times the pressure of Earth's at sea level. Temperatures reach 460 Gulf C, hot enough to melt lead. And above it all, storms, bursts of light, flashes picked up by orbiters, possibly lightning. If lightning does strike Venus, and the evidence is mounting, the resulting thunder would be unlike anything on Earth. The high density of the Venusian atmosphere would allow sound to travel well, but distort its tone. It might be louder, lower, slower. The sound of thunder dragged through a pressure cooker sky. Even Mars, dry and cold, isn't exempt. While its atmosphere is too thin for classic lightning, dust storms on Mars generate massive amounts of static electricity. As wind whips sand grains against one another, they exchange charge, a phenomenon known as triboelectric charging. Could that discharge into flashes? Could it create a Martian version of lightning? Some scientists believe so. And if it does, then perhaps somewhere in the Martian desert, a silent bolt splits the air, and the red rocks tremble with a whisper we'd call thunder. Then there's Uranus and Neptune, distant icy giants with strange turbulent weather systems. Though much remains unknown, Voyager 2's flybys detected bursts of radio signals that resemble those from lightning. Some models suggest that within the fluid depths of their atmospheres, massive ice particles may collide and generate charge, just like hailstones do on Earth. What would thunder sound like on Neptune? We don't know. But if it exists, it would carry through a sky of methane and mystery. And that's only the planets. Let's not forget the moons. Titan, Saturn's largest moon, has a thick atmosphere rich in nitrogen and methane rain. Lightning hasn't been directly observed yet, but it's considered likely. If it's there, then thunder may echo across frozen lakes of ethane, rumbling through a golden fog that never sees the sun directly. Io, one of Jupiter's moons, is volcanic and volatile. Its interaction with Jupiter's magnetic field creates massive electric currents. Lightning between a moon and its planet. Plasma arcs. Silent flashes in a vacuum.
Thunder here would not be heard, but it might be felt, transmitted as electromagnetic pulses across the void. Which brings us to the bigger question: if thunder is a sound, and sound needs a medium, then where does it go in space? The answer is it doesn't. Not in the traditional sense. In the vacuum of space, sound cannot travel. No molecules means no vibration, no wave, no audible noise, but sound's electromagnetic cousins can. So lightning in space doesn't die in silence. It transforms. It becomes radio, light, magnetism. It whispers in wavelengths we must convert to. But when we do, when probes translate those frequencies into sound, we realize something beautiful. The universe crackles. There is music in the void, static in the stars, thunder without air. And even here on Earth, we are beginning to listen to it. Astronomers use radio telescopes to hear storms on Jupiter. They decode plasma waves from the solar wind. They convert space weather into sound, not because it's practical, but because it reminds us thunder doesn't have to be audible to be real. And maybe that's the greatest lesson of all, that the roar of the sky is not confined to our blue world, that storms are not local tragedies, they are universal phenomena, that electricity, imbalance and violent beauty occur wherever energy seeks release. So yes, thunder speaks beyond Earth. And one day, when we walk beneath alien skies and see the clouds begin to glow, we'll know what comes next. We'll wait for it, not with fear, but with wonder, because even across the stars, the storm still has a voice, and the sky, even there, will not stay silent.
Chapter 25. The Storm Within. Why we listen to thunder at night. It's late. The world is quiet, and somewhere beyond your window, the sky breathes. You hear it before you see it. A faint rumble, not quite close, not quite far. The kind of sound that wraps around you, slow and low, like the earth is rolling over in its sleep. It's thunder. But more than that, it's a feeling. Why does thunder speak louder at night? Not in volume, but in meaning. Maybe it's because the world has gone still. The constant hum of life, the voices, the traffic, the noise has faded. And in that hush, thunder becomes more than weather. It becomes a kind of presence, a reminder that above our quiet houses and tucked in dreams, the universe is still moving. At night, the sound travels farther. The atmosphere cools and settles. There are fewer disruptions to scatter or muffle the sound. So thunder rolls longer, deeper. It becomes a blanket, heavy with energy, but strangely comforting. It doesn't always scare us. Sometimes it holds us. You lie in bed, eyes open, counting the seconds. Not out of fear, but curiosity. Connection. There's something about being warm while the storm churns outside that taps into something deep. It's the contrast that moves us. The dry against the wet. The silence against the roar. The calm of the body against the unrest of the sky. That contrast doesn't threaten us. It makes us feel alive. Because thunder at night does what few things can. It keeps us in the present. When the mind wants to wander to regrets of yesterday or fears of tomorrow, thunder pulls it back. Every crack in the sky resets your focus. Every distant boom brings you back to your body, your breathing, your room, the now. And maybe that's why so many people fall asleep to storm sounds. Not because they want chaos, but because they want a witness. A sound that reminds them they're not alone, that the earth is still spinning, that the atmosphere is still watching over them. It's strange, isn't it? How something so powerful, something that shakes houses and splits trees, can also make us feel safe. But that's the paradox of thunder. It represents release. All day, the clouds built, pressure mounted. The sky held its breath, and then finally it let go. In a burst of light, in a roar of sound, in a release of tension so pure it turned violence into peace. We relate to that, Because we too carry storms. We build pressure. We hold our breath. We stack emotions like clouds, darker and heavier with time, until finally something has to break. And when it does, we cry, we yell, we exhale, and in that moment we don't just survive the storm, we become it. That's why thunder resonates with us. It's a mirror. It shows us that even the sky can't stay silent forever, that holding too much always leads to eruption, that energy, unspoken, will find its way out, with or without our permission. So maybe when we listen to thunder at night, what we're really listening to is ourselves, our hopes, our fears, our inner weather, and in that way, the storm becomes sacred. It's not just nature, it's story, it's sound, with meaning, it's pressure turned into poetry. Because when the lightning flashes behind your curtains and the thunder follows, you're not just an observer, you're part of the cycle, you're part of the equation. The earth is discharging, yes, but it's also communicating. It's saying, I'm alive. And I too need to release what I've been holding. We understand that. We need that. And so we listen to the pulse in the sky, to the language of electricity, to the story carried on a rumble through the dark. Because in the end, thunder is not noise. It's translation of storm, of stress, of imbalance, of beauty. And at night, when we're most open, we hear it more clearly than ever. So when the next storm comes, let it. Don't rush to close the window. Don't cover your ears. Don't pretend it's not calling you. Let it say what it needs to say. And if it wakes you, listen, not just with your ears, but with your heart. Because somewhere in that sky, just beyond the flash and the roar, something ancient is speaking, and it might be speaking to you.